everyone. Okay, I am getting caught up here on the messages in chat. Hi, Media Only, and Mediocre Gamer, and of course Loafbone, and then Exegetic Chris. You say you're NLPing at this very second, training a morphology tagger for ancient Greek. Ooh. That sounds really cool. Alright, well, this is a great stream for you then. And hi, Icy Yogi, and Crow, and MH Zaneraman. Whew, it has been quite a day, friends. Lots of fun politics in the United States happening. COVID stuff happening with my parents. So it's been a day. But I am very glad to be here with all of you, and I'm really excited to talk to you about natural language processing. I'm an Icy Yogi. You ask how my parents are doing. They're doing okay. I dropped off some groceries for them today. It's just a matter of waiting. So, yep, we'll see how it goes. And Toasty1A, you ask, when do I play games? You mean on stream? Usually Tuesdays, but the 12 days of machine learning miss has kind of supplanted normal stream schedule. So I will probably be returning to regular stream schedule next week. And so the redemptions that you all have, the science topic and game recommendations, those are usually done on Tuesdays. So hopefully then I'll get to play some games. And let's see here. Exegetic Chris, you say there's more ancient Greek in existence than I might think. Yeah, there is. Oh, you mean like actual content? Yeah, I would imagine that there is a fair amount. I know there's definitely a lot of Latin. When it came to classics, my focus language was Latin, not Greek. And so I think the corpus there is a little bit heftier, but maybe that's just my own bias. And MH Cinnamon, yes, have I played Detroit Become Human? I have not, actually. I'll have to add it to my list. And M Brethren, you say you have two of me talking at the same time. Oh no, that sounds very stressful. I don't think I could multitask two people talking at the same time. Nice. Yogi, you ask, have I already played Half-Life Alyx with my index? I have not. Loafbone has. I've watched a bit of it. Looks really cool. Apparently I've been told I have to finish Half-Life 2 first. So I gotta finish that, and then I can jump into to Half-Life Alyx. And let's see, GV Stu, you say hello. Good evening, everyone. Hello, how are you? So let's see, what did we talk about last time? Oh yeah, duh. Graph theory and network analysis. So, as always, the first little bit of stream will be answering questions, and if there are any leftover questions from last time or any previous topics, now's a good time to ask them before we jump into NLP for the evening. And Ian Alex, all right, thank you for the bits. So, Hubble is feeling much better today. So actually, while we're all hanging out here, I'll start to get that stuff booted up, so that when we give treats, I am prepared. And Moonify, thank you for following. Okay. How are the captions, by the way? Are they good today? I always like to check. I did remember to start them before stream. Good, awesome. Because I was testing if I could pause the captions if I needed to. And so I was testing the ability to turn them off and turn them back on and see if it would still work. And apparently it does. So, yay! 3 cheers for captions. Okay, so I will get the Furbo set up over here for us, so we can give the dogs some treats. We banked quite a bit of treats, actually. I'm surprised this thing hasn't run out of treats, honestly. The dogs have been getting so many treats. Such good boys. All right. So that'll load up. Takes a couple minutes to boot up. All right. So how do people feel about, those of you who were here yesterday, how do you feel about graph theory? How do you feel about network analysis? Did it make sense? I feel like it was a lot more straightforward. Like, I wanted to have a couple of streams where topics were very more math-based and more complicated. So our reinforcement learning, our neural nets, I know those were a lot more complicated. But then I think it was nice to take a bit of a break and get back to something that was more intuitive. And I think tonight things will be very intuitive as well. So we won't be beating ourselves up with math tonight, because it's language. And let's see, Toasty, you say, who gets to go to space? Is it only scientists and engineers? I think for now, obviously given the cost of going to space, it's pretty much scientists, research scientists, engineers, that type. But, who knows in the future, right? Someday, it might be a far more accessible place to be. And Quellis, you weren't here yesterday, so you feel lost and scared. Don't worry. You don't need anything from yesterday to understand today's stream. So the last few topics, the network analysis, NLP, and computer vision, are more like case studies. So rather than a lot of the foundational topics that we covered where they were kind of built off of each other, this is not. These ones are standalone. So you might need skills or concepts that we've covered in previous streams, but not at least from these last three. And hi, Just As Good Joe, welcome. Okay, a couple things set up here. Quit this. There we go. You just want Disney World on the moon. Well, I'm not sure I want Disney on the moon, but I will, you know what? You go for it. Okay, yeah, I think we've got everything set up here. Okay, there we go. All right, so like I said, any previous questions for days 1 through, let's see, it's the 12 days. This is day 11. So 1 through 10. Let me know so that I can make sure everyone's caught up before we get started. And let's see, Icy Yogi, you say, Samantha Cristoforetti is an EU astronaut with a fighter pilot background. So yeah, a lot of times, I know there's like Air Force pilots and stuff as well. It's still, I don't think, what Toasty One was talking about with wondering about blue collar jobs. It's still, I think, like the bar to go into space is quite high. And Rafaka 1996, thank you for the bits. Hey, what's up to you too? Nothing much is up today. Long day, but it's all good. I'm excited for stream. I'm excited to talk to you all about natural language processing because this is super, super cool. My undergrad background was in linguistics, and so this is neat because this is like bringing two of my favorite things together. And MH Zannerman, you ask, what was the result of yesterday's data application and code? Only if possible. So yesterday we used a really, really famous kind of graph or network data set that's Zachary's Karate Club. And so we did community detection or community prediction using that data set. So we were trying to predict membership in communities. So kind of like you can think about it like clusters of a graph. And that's what we did. That's what we did yesterday. And Rafaka, you ask, am I from MIT? I am not. I'm not from MIT. And yes, Mr. Ed makes our green group, our black group, and our blue group. And so we talked about how we could force things to end up in two groups if we wanted, or how we could interpret that strange third group that also popped up. So there were a couple of different ways to kind of interpret the results. But yeah, I think, it's a data set that is meant to be used with graph theory. So it's kind of well designed for that. So you're going to have a lot smoother and a lot more consistent results than you would obviously with real data. So, and fire exit. Thank you for following. What a great name. Okay, so with that, actually, let's start to dive into natural language processing. And while I'm kind of getting our whiteboard here, I've tested it. So if it does what it did yesterday, I'm going to be very upset at it. Fingers crossed that it behaves today. Let's see here. Where is... Let's get... I don't need this anymore. And... There we go. Okay. Natural language processing. Woohoo! Processing. All right. Before we even get started with this, when I have taught this or, tutored people in this before, one of the things that's really surprised me, like one of the questions I got that I just really didn't anticipate was kind of, it was a lot harder than I realized for people who haven't worked with this kind of data or, worked in machine learning. It was interesting to me how hard it was to figure out tasks or to recognize what was natural language processing in the wild. And so I kind of wanted to start this with talking about why do we want to analyze, why do we want a computer to process, I'm putting this in scare quotes for now, to process language. And so it seems like, a very easy question, but I think there are so many different applications and uses for natural language processing that people don't even realize is NLP. And so I want to kind of start this off with thinking about why we might want to, what tasks, what things we might want a computer to be able to do if it could process language. And MH Zinnerman, you ask, does natural language processing include conversational difference like Deborah Tannen's books? I don't know her books, actually, so I'm not sure. But so whether or not you're familiar with NLP, like formally, why would we want a computer to be able to process language? What kinds of things could we do? What might our goals be? Like what kind of tasks would we be able to do? Or what kind of, apps or functions or kinds of analysis would we be able to do? And Fish Force Ulta 5 and Matt Stuck in the Moon Goo. Sorry, that name. Thank you for following. Okay, so I'm interested in Ermin, you say Alexa. Okay, so we might say Alexa actually combines a lot of different natural language processing tasks. So what can Alexa do? Alexa can recognize speech. Alexa can also generate speech. And Alexa can also, what is it called? It's machine comprehension. So this is, well, actually, she combines this into a couple of different things, right? She has to be able to comprehend and then combine that with a search, right? So let's see, what else? GV Stew, you say translation. Yes, so machine translation. So there's a couple different things here. This you could think of as like Google Translate, right? All three of these is something like Alexa. Speech recognition and speech generation are huge in accessibility, right? Because this is where we get text to speech and speech to text. And this search, that's going to be like Google search, right? So we'll talk also about a little bit more about how that works. Let's see. And Exegeticus, you say you use it to catch the thousands of tiny nuances that go right over our head when we're reading a dead language. Ooh, I want to hear more about that actually, because one of the things that can be difficult if you're just starting out in NLP is it's very easy to, okay, easy. It's far more simple to get a computer to understand words in isolation, but it can be a lot harder to understand context and nuance and like implication and things like that with language. That's a lot harder. And so, oh no, Daraj, I'm sorry, I didn't mean to trigger your echo dot. So actually, subpar, you say OCR, but here's the interesting thing. Optical character recognition is not, you could combine that with NLP, but optical character recognition is actually a computer vision task because it deals with processing images and extracting information from images. Now, you might want to run some NLP on that, say, to correct typos, right? So this is where we would want like misspelling or autocorrect. And Accent, you ask, am I going to cover NLP algorithms for all these tasks? Goodness no. All right. This is like what we're going to write here is probably what could be covered in an entire giant textbook. And that could be a whole 12 days of NLP, honestly. So you'll see. We're not going to do it for every single one of these because some of these tasks are also very difficult and require more complicated approaches. Some of them are more simple. And Icy Yogi, you say information extraction may be different than searching and comprehending. Absolutely. So what you're talking about, information extraction, could be a couple of different things. So that could be, oh yeah, sometimes this is called, hold on, search. This is sometimes called data retrieval / search. So let me think of, so you might be talking about like summarizing, or you might also be talking about, just keep going down, identifying important elements of a text, or key themes, things like that. So that could be information extraction. Text recognition. What do you mean by text recognition, Diraj? And so, ICOG, you also ask about DNA sequencing. Well, just as good, Joe is here to help us out with any kind of cool biology or bioinformatics questions. And yes, you can use NLP approaches to a whole host of different problems that have nothing to do with language. And that is really cool. But I'm thinking strictly language-based tasks right now. And let's see, catching, Exegeticus, you say, catching semantic preferences and understanding article usage are two things you specialize in. You say, we don't have a good grasp on how ancient Greek uses the word the. Okay, the article the. And you say, I'm taking a novel approach towards explaining and wrapping that. That sounds really cool. That's also very interesting because a kind of standard approach in a lot of base level machine learning tasks or NLP tasks that we're going to be using tonight involves removing filler words like that. And we'll talk about how we're going to do that. But the is often, and other articles like a and an are often considered filler words and are often removed. So again, Diraj, the handwriting recognition is going to be another computer vision task, mostly because it's about comparing handwritten characters to typed characters, and it doesn't require a knowledge of language. Now, you might have on top of that NLP to do autocorrect or like spelling correction to make sure, like if you've missed a word or missed a letter, your CV model has misidentified a letter, that the NLP will catch it. But I wouldn't say that it's NLP kind of entirely. Trust Star, thank you for following. Needy only, yay! This is the first thing you've understood. I'm so glad. This is very intuitive, I promise. It's gonna be really, really, really intuitive. So other things that we could do, let's see. So chatbots, right? So like sometimes when you go onto a website or something, there's a little bot that comes up that's like, hi, do you need help? What can I help you with? And they're so annoying, but that's a thing. What else? What else can we do with natural language processing? Let's see here. Seeing if we missed anything. I made kind of like a starter list just to make sure the big ones we hit. Sentiment analysis. Yes. I'm so glad you brought that up because that's something we're going to be doing tonight. Because it is, yes, you say, usually the first application example. And this is really, really interesting, actually, because there are a lot of different ways of approaching it. And we're going to use kind of a model type we haven't used before, but it's very, very interesting because the basic model types can do quite well, but there's a lot that, sarcasm, for example, or kind of what we call like the pragmatics in linguistics, so lies or forms of speech that are not straightforward, essentially, exaggeration, things like that can be very difficult for computers, especially when you're talking about sentiment. Understanding intention and sentiment, yes. And MH Cinnamon, you say aimed advertisement based on individual information. So some of that, I'm trying to think of, are you mean like the advertisement text is generated? Because that's definitely, we can do, I think, do I have text generation on here? I don't think I do. We can do text generation. So I'm sure that at least some of you have read some of this in the news about text generation NLP models that can generate very authentic looking text and the problems that might pose for things like deep fakes. Deep fakes are not just images. Deep fakes can also be text, and that can cause loads of problems. All right, let me see if I missed anything. Sentiment analysis. Yes, we talked about that. Chatbots, summarizing, autocorrect, text. Oh, text. Did I say text prediction? Because that's another one. Text prediction. Autocomplete. If any of you have Gmail, I don't remember when it was. I swear it was last year, but maybe I'm just like not remembering. 2020 also feels like it was a decade long. But Gmail has now started to do text prediction. So when I'm writing an email, it'll, based on all the emails I've ever written, it'll start to try to autocomplete what my sentence will be. And yes, you're exactly, Goofy Lagrangian. That's what I was thinking of as GPT-3. Let's generate some replies to your work emails. Ushtua. Well, given how accurate Google, which has lots of, hardware and lots of people working on this, given how accurate theirs is, I would not want autocomplete to be just without my control in my work emails. Okay, so Icy Yogi, you say forensic analysis to find, for example, anonymous authors of text and vice versa. Make text looks like it was written by another person. Okay, yeah, so like that might be like you're thinking kind of like author prediction, or I'm wondering what that might, like the technical term for that. But we're just being casual. Just say author prediction. And let's see. So yeah, like the forensic, I'll put that there too, because forensic classification. Forensic sometimes gives people like this crime implication, even when that's not always the use of the word, so. And Image Cinnamon, handwriting classification, again, some of that is computer vision, and I know it's tough because like most of us interact with text through an image of some kind, but that would actually be more of a computer vision task. And Bucanel, thank you for following. Okay, so there's also there also are, you might hear some of these terms that I just wanted to put here as well. I hear these less so, but also I don't do a lot of NLP myself. So natural language understanding, NLU. So this would be kind of like what were we talking about? The machine comprehension that I said earlier. and also natural language inference. And this is really cool, actually. So with natural language inference, I'm going to change colors. This is a lot of like a very boring color. So with natural language inference, you can do things like relationship or relation extraction. So identifying the relationship between words or phrases. You can also do things like semantic role labeling. So this is really interesting, like identifying the relationship between, like, say, a phrase and a word. Like, it's very easy for us to understand if I say, wow, I like the sandwich or the sandwich that's full of cheese and vegetables. I don't know, I'm hungry. But to understand that full of vegetables and cheese or something is related to and connected to sandwich is something that's important to do. And let's see, Hanny Copes, no worries. Yes, you see, you missed all of the days. Here you go, friend. So I got you. We have a YouTube command. All of the VODs are on there. If the VODs are still available on Twitch, I'd recommend watching there because then you can see the chat, the code, and the images of what I'm writing on here are also available for you on GitHub. So everything you need is available for catching up if you need to. And Ian Alex Hart with the bits. Let's see if the dogs are ready. Loaf Bone, do you think we could have a dog break? What do you think? Can we have a dog break? It's been so long since we've had a dog break. I think that could be really fun. Let's see. See if the boys pop up on camera. Let's see here. Because we owe them a lot of, oh yeah. Okay, here's Hubs. Come on, Hubble. Okay, come on, little boy. So we'll do a little dog break for Ian Alex Hart. And cheers, MH Cinnamon. I will hydrate. I see him limping. Oh, poor baby. Oh, baby Hubs. I mean, he's 4 years old. He's not a baby, but he's my baby. Little limping boy. Oh my God! Don't drop your tail. This is happy. Okay, there we go. Here you go. You get all the treats. I don't care. We've banked like 8,000 treats at this point. He does. He deserves a Kong full of peanut butter. I want to get him to the point where he catches it. He catches the treats. And Hanny Copes, I'm sorry, Mr. Question. You say you're really a beginner in Python. Yes. So the code that we're going to be doing today is more simple. And when I do these teaching streams, I really avoid trying to do super like idiomatic or super like Pythonic Python, so that if folks are kind of new to programming specifically, they can still follow. So I really try to spell things out. So don't worry if you're new to Python. I try to keep the Python really simple. There's something else I was going to say. Oh, yeah, because, machine learning is interesting because a lot of folks who want to learn about machine learning, okay, I'm sorry, baby. I'm not giving you treats fast enough. Thank you, Dudin01. But a lot of people who are interested in machine learning either don't have a programming background or, are like software developers wanting to transition. So, oh my God, I'm sorry, my dog is really cute. Oh my goodness. He's so perfect. I'm trying to give him more. I'm giving him treats as fast as I can. Do the treats actually do anything? Yeah, it spits out a treat. It actually, like, the camera will throw a treat for him. So hopefully it's not empty. Let me see. He's looking impatient. I love you, Hobbs. Don't go away. Don't go away, handsome boy. Sometimes I don't think it throws it. So I think sometimes it gets, if I maybe do too much, it's like, okay, I'm trying, baby. Oh my God, stop looking at me like that. He's so cute. Come on. I'm trying. Why isn't it working? It might be out. Oh no. Okay. Well, we'll take a pause So, Lofa, would you want to give him a Kong? Would you want to give him a Kong with also his nighttime meds in it? I know, because I can't look at this anymore. This is going to destroy. Oh my god, he looks so sad. Okay. I gotta resist. He's so cute. Oh, don't play Bao. Oh my god, he's so perfect. Okay. Nope, we're doing Loafbone will give him a Kong. So it'll be good. And we'll get more treats in it, and we'll come back when it's fixed. And Handycups, he can't see me. It's just a camera. I can talk to him, so I can use a microphone and talk to him, but he seems to just kind of be weirded out by it a little bit. He's kind of like, the hell is this? I don't see you. I don't have to listen to you. So it's kind of funny. And Zavanok, thank you for following. Okay, so while we're waiting for the troubleshooting of the Furbo and a refill, and hopefully a Kong stuffed with peanut butter because he's a very good boy, we've talked about a lot that natural language processing can do. And so to accomplish, well, actually, before we even get there, before we even get to the happy stuff, let's talk about, we've talked about the amazing things. We've talked about, the world is our oyster, all of the amazing things we could do. What would be some of the challenges that you anticipate? Even if you don't work with natural language processing, I think a lot of you who've been here for at least a couple of streams have gotten a handle on like what data is challenging, what kinds of tasks are challenging. And if you are more of a language person, what might be a challenge of trying to work with language in general? Clean data, yep. So I think I was using little stars, so we'll keep up the stars. Cleaning or having clean data. And what do you mean by clean data in this sense? So, when we've worked with our numerical data before, that's been things like not having missing fields or not having, invalid values, things like that. What do you mean by many possibilities? Just as good, Joe. Let's see, what else are challenges working with language data? Oh my god, they're so cute. No, I've got to I can't look at the Furbo camera. It's distracting. This is also why working from home is wonderful, but I miss being able to work outside of the house, not like in an office, but like in a coffee shop, because Hubble will come up to me and make the face that you just saw there. Like he just goes like this and gives me these puppy dog eyes and is like, please give me treats. And I'm just like, I'm working, stop it. And he'll just like rest his head on my lap and be like, walk, can you play with me? And I'm sitting there like trying to do work. So clean voice without noise. Yeah, okay, so for audio data, that might mean cleaning out noise. What else might it mean? So let's see. Okay, so GVS2, yeah, you say doing math with text, like math plus text, right? And that's actually a really great point, is that we're used to having limited amounts of string. So that's just, if I say string here, that's just programming language for text. But when we're dealing with text data, we're used to just having it be very limited and easily converting everything into numbers to feed into our model. So when we're talking about what happens if your data set is a book? What do you do there? So yeah, that's absolutely a great challenge, is how do we even work with string or text data? What else might be difficult? I'm hoping some linguists are in chat. Let me see. Is MC Childs here? Because he will swoop in here. I don't know if he's able to join us today. He's my friend who's a linguist. And Jordash, you ask, or Jord Ake, you ask, I'm an astrophysicist. I was formerly, yes. That was my graduate education and research. And my specialty was active galactic nuclei. So I was an extragalactic astrophysicist. And my focus was on supermassive black holes that are at the center of galaxies and their relationship with their host galaxies. So, yes, black holes. Black holes. Okay. So I'm gonna fill in one of these then. As a former linguist, at least, I can I can fill some of this in. So what about, how do you get a model, a computer to understand that sit, sat, sits, and sitting are all from sit? There. Okay. Oh, and it saved chat. Hold on. I can catch up with chat. Are you able to see I'm here? Please. Did I lose all of you? Oh, we're back. Okay. Oh my God. That had to be, I think it was a Twitch issue, because when I tried to restart the stream the first time, it was like not accepting Twitch settings, and Streamlabs was telling me something was up with Twitch. So I signed out, quit, restarted, signed back into Twitch, and now it's working. Goodness. And so some of you said it wouldn't be hard to keep like put the VODs together for YouTube. So I will probably be relying on some of your help, those of you who know a lot more than I do about this stuff. I know nothing about video production or any of that. But hopefully it will be it won't be difficult to put the two videos together so that folks can, I don't want people on YouTube to miss out on the first half of this. So okay, goodness. All right. Well, 2 now, back-to-back days of tech problems. Thank you all for sticking with me, because goodness, all right, I appreciate it. You weren't all just like, screw this, I'm gonna go to another stream. So I appreciate all of you being here. Thank you for coming back, or staying. All right, what were we even talking about? Challenges, that's right. So these are the challenges we've talked about so far with language, but there's a lot more, right? Think about those of you who maybe have tried to use Google Translate between two languages that you're fluent in. You'll notice that the translations aren't always accurate, right? Language is hard. What do we mean by hard? It's complex. It's changing. There are things like dialects. Oof. Go. Meaning can require what we would call paralinguistic features, right? So this might be things like, I'm just loving the arrows today. Hold on, I'll just change color. These can be things like tone, facial expression, that can change the meaning of a sentence. Like I could say, oh yeah, you're great. Or I could say, oh yeah, you're great. Same words, different tone, different meaning. So language is difficult, and especially when we only have a part of that. We only have text, for example, and we don't have maybe the tone, or we don't have the facial expressions. That can be difficult. And hi, Third Tier Gaming. Oh no, you said, want to hear the pun you made that broke Twitch earlier today? Oh geez. And oh yeah, don't even get me started. The whole changing, like language is organic. This is something we'll see later in the data set that we're going to use, but things like not just changing as in words have meanings and they change, or slang, but even think about how things like emojis have changed communication, right? There have been like, there's a Twitter account that I think does like summaries of classic literature, and it's all in emojis. So there's a lot more to language. And Onad, you ask, what about sign language? And so I'm so glad you brought that up, because strangely enough, the field of natural language processing seems to have a bias that's very common in linguistics, unfortunately, which is a preference for what we call oral spoken languages. So oral spoken versus gestural languages. So like a signed language. And so I've seen things like, again, computer vision approaches, not natural language processing approaches, for doing gesture detection for signed language. But a lot of, the deaf community in general has kind of said that a lot of these attempts have been not very accurate because a lot of times it's hearing people trying to make technology and they don't really understand sign language. So the real Earl of Argyll, thank you for following. And Hanny Copes, or hold on, I don't want to miss, Needy only say, do regional interaction differences fall into one of these categories? Regional interaction differences. So are you talking more like kind of like dialects, or what are you thinking? Because I mean, even just like some people say pop, some people say soda, those kinds of, maybe we wouldn't necessarily, I mean, I would call them a dialect, but those kinds of regional difference absolutely make language complicated, because what means like my Nana used to say this all the time, is that to me, a creek is the stream in the that could maybe be in your backyard, and sometimes I wake up with a crick in my neck. She would say there's a crick in the backyard and you wake up with a creek in your neck. So even just some of those regional differences. And Katya Zero, as you say, you're deaf. Yeah, so, I mean, I'm hearing, so I don't want to speak for the deaf community, but this is something that I've seen. I'm more active in the disability community on Twitter, and I've seen these criticisms come out repeatedly when technology is created to translate sign language, or those like gloves that are supposed to translate sign language, that often really fall flat because they're not made not only with the inclusion of the deaf community, like having, deaf developers and stuff working on it, but often they're made without an understanding of how signed language works in the first place. An infinite star code, thank you for following. And so Mr. Ed makes you say bubbler means drinking fountain. Yeah, so things like that. And Jordan, you say, not to be rude, but I'm ignorant. Wouldn't the deaf community just use text? Well, so you say text, that implies a lot of things. That implies the socioeconomic access to be able to have a phone. That also implies that somebody writes as well, so that they're able to kind of like write the language. When, as much as it's called American Sign Language, the grammar, the structure is completely different from English. It's not like a one-to-one. You don't sign like, oh, here's the sign for I, here's the sign for have, here's the sign for two, here's the sign for dogs. Like and Loafbone knows some sign as well, so he can jump in here. But the actual grammar of the language is completely different, and so that can be a challenge as well. So I would say it's a very complex issue, and I would recommend listening to the deaf community first on issues related to signed language in general. My advisor, actually, back in the day, in undergrad, was working on adapted signed language, so that disabled people who had limb differences, or who didn't have full mobility in their hands, would still be able to, like if they were deaf as well, they would still be able to sign, even if they only had use of, say, one arm. So maybe somebody who had a stroke, or somebody who, has one arm. And so he was working on adaptive versions of sign, which was really interesting. But okay. Hi, Alt4. How are you? I have a small ecosystem in my neck. Well, and let's see here. Hanny Copes, yes, thank you for highlighting Loafbone. Chat was going a little bit fast for a second. So you're from Lebanon, a native Arabic speaker. Have you researched about Aramaic and Phoenicians? So oh man, you're bringing me back to college. So my undergrad actually was in North African linguistics, so I focused on Arabic and French. So my focus was more Tunisian Arabic, but I speak a bit of Fusha still. Oh my goodness, yay, thank you, Stern Finger, for donating. I'm glad that you're able to watch these and do homework. Please do your homework, of course, that's very important. But I'm so glad that you're enjoying this while doing homework, because homework can be, but to finish your question, Hanny Copes, yeah, I took actually a class that was Indo-European linguistics, and so that's when we went really far back and talked about kind of like the foundational sort of like mother languages, if you will, that led to more modern languages. And it was really, really interesting. It was hard. It's very, very hard. And that's the last time I remember really studying anything having to do with Aramaic or anything about the Phoenicians. And you say, have I read this? I will pin this to read after stream, but I have not read it. And I already kind of agree with the claim there, because same thing with Tunisian dialect, honestly. That's why I kind of like that a lot of times it's hard to describe. I think it has to do a little bit, there's some prejudice behind it, but what we call Arabic dialects, I mean, there's like more than 70 of them. So there's a lot. And like when I was studying Tunisian Arabic, if somebody tried to speak like Saudi Arabian kind of Arabic to me, I would not be able to understand it. Like if we could both try to speak Fusha, which is modern standard Arabic, but we wouldn't be able to understand each other. And so to me, that like crosses a line where like, especially with Tunisian, which has Tamazight and French influences as well, it's more of its own kind of language. So Handicops, in linguistics, it is considered a dialect, but I think that there are arguments to be made there for sure. Okay, so let's keep going here. Yeah, I know there's a lot of French influence in Lebanon. Also, I don't know if this is accurate, but at least I remember learning that Lebanon is kind of like almost like the Hollywood, like that's where a lot of like art and movies and music are made in the Arab world. And so I remember watching a lot of Lebanese movies and liking them, but it's been years because my fluency is very bad now. Okay, so language is hard, and we've talked about how language is hard. And so that means that, you know, when our data itself is really complex and difficult, it's going to be hard also to build models off of this. But there are also some other challenges, right? The data is unstructured most of the time, right? So the data that we've been dealing with so far, it's kind of been, we've had our hands held a little bit. We've been able to just, have these things that are very easy to convert into arrays or very easy to kind of turn into feature vectors, but language is unstructured, at least from a machine learning perspective. Before all the linguists jump into chat to tell me how wrong I am. Obviously, language has structure, but we mean unstructured in the machine learning sense. Let's see what else. I said context. Yes. Okay. So are there any other the other one is that think about like something like the Google search engine, right? How big of a data set does it need to be able to like learn all of these different convoluted questions and search queries and words and everything? So like you also, for more complicated NLP tasks, you often need a lot of data. And that could be another challenge. And V Galvez, you say, funny that one day I followed Gmail suggestions to write an email was flagged as spam. That's really funny. And so, okay. So those are the difficulties. Now let's talk about, so we've talked about challenges. We've talked about our goals, like what cool things we might be able to do if we could get computers to understand language. And so this is going to be some of the approaches or strategies. So these aren't necessarily models in and of themselves, but these might be kind of approaches or strategies, techniques, tools that we can use. And man, I need to change up these colors. Hold on. We need some color variation here. It's got to be really colorful. Oh, and we lost our music. It's funny, I streamed for years without any music, and now I'm just getting so used to it that it feels weird to not have it up. Okay. Thank you, YouTube. All right. Okay. So what kind of approaches or strategies can we use? So one of the things we can do is something called part of speech tagging. And so any guesses as to what that might do? Essentially what it does is it takes a sentence and it tags what part of speech the different words are in. And so that's very, very helpful for figuring out relationships between phrases. It's also really, really helpful when figuring out hold on. The word just fell out of my head. Stemming. There we go. Goodness gracious. And let's see here. And Handycopes, you say, sorry, question off topic. No worries. It's okay. But any particular resources you use for beginning physics studies? Also for linguistics. So I would say jump into Discord so we can have a more like in-depth conversation about it, because there's a lot of different recommendations and it depends on your interests and all kinds of things. And yes, I consider Noam Chomsky a linguist. I think universal grammar is BS, but he's definitely a linguist amongst a lot of other things. And Pile of Kyle, what a great name. Thank you for following. Okay, so stemming is what we can use to, like, remember the problem that I just kind of described of, like, how do we get a computer to understand, sit is also related to sits, also related to sitting. So stemming is one way that we can do that. And the other way that we can do it is lemmatization. So we're going to go into depth a little bit more about these two different approaches in a moment, but I'm going to put them here for kind of like root word identification. That's what we'll say. And let's see here. What else? So we can use, named, this is really cool, named entity recognition. As well as linking entities. And so this is where, there we go. So this might be where maybe I'm reading an article on, I don't know, the history of Notre Dame, the cathedral. And if I were to run named entity recognition, it would probably recognize that France, Notre Dame, whoever like the architect is, right? And it also might recognize that those are linked entities, that they have a relationship. And so this is very useful for kind of some of that meaning extraction. You can also use it for the inference tasks that we were talking about earlier. So being able to understand complicated relationship between different parts of a sentence. Let's see what else. So tokenization. So this is where you break your text down, or you segment your text into subcomponents that are called tokens. Okay, let's think. What else did I want to make sure that we talked about? Part of speech tagging, blah, blah, blah. Oh yeah, so we talked about this earlier, but stop word. So this is what I called filler words earlier. They're called stop words, so stop word removal. So stripping out some of those filler words from our sentence. We can also this is a long word for something that's really very simple, but you can do, I always reverse the term frequency. Inverse document frequency. And this is usually like you see it as TF, IDF. Okay. And term frequency, inverse document frequency, is used to identify word importance. Okay. And some of this other stuff we'll get to. So, all right. These are just some things that we're going to be talking about. But in terms of, I'm gonna just check where I am in my notes here. Okay, yeah, all right, looking good. Hi, Martin Eden. How are y'all feeling? We've talked about kind of like the natural language processing tasks. We've talked about the challenges, and we've talked about some kind of like sub approaches or approaches that we could combine to break text down and make it easier to work with or to get more interesting things from text. And so Mr. Ed makes you ask, are you going to cover how to tell prefix as modifier as opposed to part of a word, like a float versus a void? So we aren't going to go into as much of that tonight. We're going to use some of these strategies to kind of do a more complex task. And SXRS2, thank you for following. Okay, so I want to cover just a couple of terms before we jump in there. Come on, just 100. There we go. So that when we are using some of these methods later or some of these libraries that you kind of understand the terms being used. So let's see here. We've covered some terminology already, but here's a little bit more that we might be using. So you're going to hear things, you might hear things referred to as a corpus, right? This is kind of like just your data set. Now, you have to kind of broaden your mind a little bit when you're thinking about a data set, because this could be, it could be a blog. It could be, I think one common data set is like Yelp reviews. It could be a bunch of separate pages. It could be a bunch of books. It could be all kinds of different things. So it's, corpus is very broad, and it really is kind of project dependent. Let's see. And Hanny Copes, you say, don't you think it's annoying that there are no free resources out there for learning physics, math, science? I know there's Khan Academy, but I feel like there should be more. I think there are some YouTube channels, but I'm not really somebody that learns from videos, so I definitely, I feel your pain. And ONAD, corpus is Latin. If I'm remembering right, it means body. So when we talk about like a body of work, right? Corpus is kind of interchangeable there. What else? Okay, so the other thing that we're going to be, I don't actually think I ended up using bag of words, but so you're at least aware of it. This is really common. You might see this if you like Google NLP tutorial or something. You might see this. And so this is something that doesn't consider word order at all, but instead it's gonna grab the frequency of word. Oh gracious, that's not a word. Occurrence. Occurrence is with one R. That is, I don't know why that's. I struggle with words that have two like embarrassing and things like that, where there's like double. I want to give every single letter a double. So anyway, and Martin Eden, you ask, am I working in daytime? I am. So I work full time, and I've been on holiday for 2 weeks, so I was able to do a lot more streams. And yeah, this week I'm back at work. So if I seem a little more tired, I'm sorry. And Hanny Copes, do you say your friend keeps saying your grammar sucks in English? You just can't fix it for some reason. You try, but you always mess up. Are there any good ways of doing so? Absolutely, practice. I know that sucks. I know. The more that you speak English, you listen to it, you write it, and you read it, the better you'll get. And I feel like that with my Arabic, so I definitely feel you. And Ian Alex Hart, thank you for the bits. The Furbo hopefully is going to be refilled and fixed soon, and then we'll have another dog break. And Risky Banana, hi. Okay. Also something you'll see, engrams, which I love that word. I don't know why. I just really like it. It looks like it should be a yummy word. And these are just sequences of characters or words. Yumgrams. I know. I don't know why. It's a yummy word. It just is. I don't know why. And Martin Eden, you say, oh, you live in Europe. Oh, no. And it's 4 a.m. for you. Oh, my goodness. I'm so sorry. There are VODs, so you always are more than welcome to watch the VOD, jump in Discord, ask questions. Like, I try to be really responsive, so I'm here to help. And J Holly 218, thank you for following. Okay. So n-grams. There are a couple kinds of n-grams. So you might see a character n-gram. So that's going to be like a single character. Might see a bigram. That's 2 words. What else? And then, oh, right. So you might ask, well, why are n-grams so important? Well, this is really useful when you don't want to just split on word. So if you think about it, we have a sentence like the word mouse, for example. The word mouse could be, based on context, it could be like a little squeaky mouse, or it could be a computer mouse. And so sometimes we're going to want to include other words, not just have a list of words. So like data scientist, right? You could be a research scientist. You could be a chemistry scientist. You could be a data scientist. And so having that extra modifier is important with some words. And so that's why we want things like n-grams. And Alda4, you say, I'm not the only stream who lost. Okay. What the heck? Well, I'm glad that it wasn't something on my end for once. It wasn't like my technology just dying. But that was so frustrating. Like, yesterday my tablet died. Today Twitch dies. Twitch has been struggling. Like, there's been... Maybe it's just that I'm streaming a lot more, so I notice it. But there have been a handful of days, even in just like the last month, where it's gone down, like it's just died, all kinds of issues. So, and so Hannah Coops, you say, are there any studies tracing older languages, Proto-Semitic in particular? Oh, I wish my friend Matt was in chat, because he really, he would know this stuff, because he's continued to kind of follow his linguistics education, where I switched out of linguistics a little bit. But I can try to find some resources for you, especially like the resources that I used in some of my classes. He is on Discord, so if you hop into my Discord, I can tag him for you. Okay. Had to reboot the Matrix. Oh, Twitch. All right. What else do we need to know? So I think this is kind of intuitive, but just so everybody is on the same page, when we're talking about our units here, like our units of text, you can think that like maybe the smallest unit we might consider is a character. Then we might have like, we could have like prefixes, suffixes, like smaller combinations of characters. We'll have a root of some kind. We'll have words, obviously, phrases, sentences, paragraphs. So this is really this is one of the ways that we can look into kind of putting structure into what might appear to be unstructured data. And what we were talking about like 5 minutes ago, stemming is this is where we were talking about kind of finding the linguistic variations of a word and being able to identify the root. So stemming in particular seems to assume that there is a stem for the word and then it drops things off the word. So that's fine, because we might get things like crying and that'll go to cry. But it also means if we feed cried to it, it's going to give us back cry. So stemming Stemming is faster, but makes more mistakes. So there's another approach called lemmatization. I always need to make sure I spell that right. Yes. And so this uses more complex rules. Oh my goodness. Rules. What is up with me today? My handwriting's all over the place. Whew. It's been stressful lately, folks, so I just gotta calm down. More complex rules to extract what it calls the lemma. What it thinks of as like the real root. What we think of as like the linguistic root. And oh no, thank you for following, but I have no idea how to pronounce your name. Maybe if I hover over it. Sometimes that'll work. Nope. Okay. Well, I am sorry. I don't know how to pronounce your name. I think that's Korean. I don't read Korean. But welcome anyway. I am glad you're here. And so this is going to be slower, but it's actually going to be a lot more accurate. So actually lemmatization can do things like take the word better. And a lot of times you have to feed it the part of speech as well. So we might say like comparative adjective, just adjective. And it'll give us back good. So it's not just about roots here. It's actually about like root meaning, the original form of the word. And I think I saw some folks talking about this earlier, but vectorization. Sure I'm spelling this right too. And so this is, I think people are talking about like word to vec and things like that. This is about how do we convert text to a numerical input for our model. And so, for example, one approach to this is something called a count vectorizer, which now I'm just thinking of like Count Chocula, like that it's a count, like a count is in the title. So somebody should draw a picture of that, who's not me. But count vectorizer would be like, maybe we have, I don't know, let's see. I was trying to write there, like book 1. Oh, I'm real creative tonight. Look at this, book 2, book 3. I even made a note to myself with, come up with clever example. And then I read my notes, I was like, my brain's not there tonight, friends. My brain wants to play video games, but I'm here for all of you. And NLP is very cool. So we might have the word, well, now I'm thinking of Count Chocula, so chocolate. Maybe we'll have the word dog. We'll have the word car. And we'll have a technical term here, galactic. Yeah, let's do that. Why not? This is an awesome series of books, whatever this is. Welcome to my brain, literally. I don't know why car is in there. But okay. And so then we would have the count of these words in the various books. And so maybe book 1 is it's going to be a space-themed recipe book. And so chocolate's going to appear 82 times and galactic's going to appear 15 times. And maybe the person like references their dog. And book 2 is going to be like a post-apocalyptic survival book with a guy with a dog, because that seems to always be the case. So we're going to have 90 occurrences of dog, maybe like 37 occurrences of car, and maybe like 2 occurrences. Oh no, I already used 2. Crap. 4 occurrences of chocolate, because maybe the guy misses chocolate or something. And then our last book would be sci-fi novel, going through space with the space car. So there we'll have like 92, or let's actually make it like galactic. Nah, we'll make it even more, 117. And our intergalactic space princess has a really cool space car. So we'll have 73 instances of car. Maybe somebody's face looks like a dog, so we're going to say 8 for dog and something maybe chocolate used as a color or a descriptor or something, so we'll have 11. So I made it. Screw you, past Jess, with the come up with a give example of, and I'm like, oh, all right. And so, thank you, Alta, for I don't think I'm very great at improv, but I was thinking Hitchhiker's Guide to the Galaxy, but yeah. In any case, Damage Engine, thank you for following. So this is one way that we could take a large complex corpus of text and convert it into a feature vector, is that we might have either, instead of just 4 words, we might have like a massive list of words that we're interested in, and our feature vector here would be either by word or by book what the counts of various words. And so this can tell us a lot of things. For example, is this where I came up with the example for this or no? Screw it, I'm going to give no, that's an example later. No using that example yet. I did actually come up with an example for later when we're doing some statistics. But okay, in any case, maybe I want to predict if my book is a sci-fi book or not. And so I might have a list of really common words in sci-fi novels that was made through NLP analysis of sci-fi novels. And then, maybe I look at the top 200, most common words used in sci-fi books. And then I use that and do a count vectorizer to look at other books and, compare the frequency of the most common sci-fi words. Things like that. So this is one way. There are plenty of different ways that you can do vectorization, and they can get very, very complicated. But I just wanted to show you a very intuitive example of how you can take text and you can convert it to numbers. And so MH Zennerman, you say, do we divide by number of words in each book to get relative frequency? You absolutely could. Yeah, there's all kinds of different ways that you can do this. So I am going to switch here real quick. So today is going to be a lot more code than Blackboard. I know. I've been hitting y'all upside the head with the Blackboard lately. Oh no, come back, little pen. So I thought I would have a little bit more code this stream. So folks who aren't programmers, who don't know a lot of code, don't worry. I tried to keep all of the code very simple. If I, made something that doesn't make sense, you can always ask questions about it. Go for it. But one of the goals of these streams is to make them as accessible as possible. So I actually went back through my code, took out a lot of the stuff that was really sort of idiomatic or Pythonic or, me just being kind of lazy, and tried to make it very, very, very clear. So even if you don't know how to code, one of the good things about Python is the syntax and my variable naming should be intuitive. And so hopefully it will make a lot more sense. And the Smoldering Sheep. What a name. Thank you for following. Oh, okay. I'm just going to get our little environment thing up. Today is day 11. Yes, day 11. Yes. Yes. I can count. I can math. And Alta thank you for the gift sub. Welcome, Setzer Bomb. Yay. Now you have a sub. Thank you. Let's see here. This is I just said day 11. We are doing NLP. And I'm not going to forget this time to zoom in. 150% seems to be what folks have requested. So I'm going to move my notes over here for once so that I can actually read them. So we'll go here. Organizing all the things. Somehow, you know what? Streaming always makes me think that I actually need more than 3 monitors, which I don't. I don't need 3 monitors are more than enough, but it never seems to be enough room to have all the things that I want. For the codes, yeah, woohoo, we're gonna do some coding. Okay, so here we go. We're in happy coding land, and we're gonna use a library. I think it's actually Apache, NLTK, And we are going to use, this all should be downloaded already, but just in case. You're gonna like me? Yes, you liked me. Thank you. Okay. And so this is gonna be, examples of Twitter data. And so we're gonna have 3 different files here. We're gonna have negative tweets, positive tweets, and then all the tweets. All the tweets. Needs more galaxy color. I wish I could have like galaxy color in here. I know, I'm sorry. And thank you, Juan Echo Peru for following. Where else are you gonna store all your extra Firefox tabs you're never gonna look at? Oh God, I feel called out because that is 100% me lately. And I've tried all kinds of things like pinning tabs, and there was one that was like 1 tab where it would just store it, and that would mean I would never look at it again. I've tried bookmarks, I've tried everything. Like ADHD plus massive amounts of curiosity is a bad mix. Just means that there's like a lot of things that I click, I'm like, oh, I should read this later. And then, fast forward a week when I've got like 500 tabs and I'm like, I should clean this up. And I just like delete everything. But in any case, and Apple Master 2000, you ask, what language am I programming in? I am programming in Python. So Python is the most common language for machine learning. So for a 12 days of machine learning miss, I'm going to be using Python, and we're going to keep the Python really basic so that even if you're brand new to Python or you've never written code before, hopefully this will make some sense. Okay. So we are going to have our positive tweets. Let's get our positive tweets. And we're going to call it aptly positive tweets. All right. There we go. Okay. And then we're going to have negative tweets. And we're going to have all the tweets. And thank you for following Apple Master 2000. Welcome to the stream. Oh God. Hell no. I'm not writing that out. I'm gonna freaking put some kind of awful typo there. All right. Okay, that worked. So let's take a look, right? Why would I be interested in comparing the lengths of these? There's many reasons, but from a machine learning perspective, why do we care? And I will answer some chat questions while I'm doing that. I'll just put this over here with the rest of the fire. Oh God. Story of like way too much of my life, honestly. And Axet, you ask, am I covering transformers today? So today I'm going to be doing more basic natural language processing, but if the 12 days of machine learning miss has taught me anything, it's that all of you want more. And so I think a more advanced natural language processing stream would be a good idea. So I can cover, transformers, like encoder decoder stacks, which is I think what you're talking about. We can talk about embedding, different ways to add what we learned about with the neural nets into natural language processing. But just like with reinforcement learning, and honestly just like with the neural nets, you gotta know the basics first. And French AQP, thank you for following. So that is one reason that we're going to start with more simple natural language processing today, so you can get a handle on the approaches, the concerns, things that might happen. And then when hopefully the 12 days of machine learning miss is successful and has concluded, I can start to plan some of those extra streams. So the reinforcement learning and Doom stream, for sure, that'll be probably a couple of streams. Maybe doing some more natural language processing as well. I've actually built transformer, like pretty deep transformer stacks from scratch. So that was actually very educational. I did that to myself because I wasn't grasping. I felt like I wasn't really understanding what all of the different layers were doing. So I was like, screw it. I'm just going to code this. Bali Baba, thank you for following. All right. Let's see. Yeah, there's no more pog. No more pog. You can't be racist and be here. We will yeet you. And Martin Eden, you say, am I familiar with the Pygame module? I haven't used it myself, but I have heard of it. So I've actually never done any kind of game dev in Python. And let's see here. And Exegeticus, you say that would be awesome because you don't have a great grasp on them either. So funny story here. You'll get a kick out of this. Hold on. So literally, I showed this on stream the other day, but this was me understanding, you can even see my gross handwriting, transformer architecture. So this is me drawing endless pictures. This is like the 5th attempt, by the way, to draw this stuff. And this is me figuring out how all of these different layers work together, how the different stacks work together. Also like multi-head attention stuff, which attention's like a really cool thing. Yeah, so that was fun. There was lots and lots of ugly pictures of me going like, how does this all work? And then I was like, damn it. Like, no matter how many pictures I draw of this, I'm really not getting it. So I was like, all right, I know what this means. Time to just do it all from scratch. And it's going to be painful and it's going to be gross and it's going to take me forever. But then at the end of it, I was like, oh, I get this now. Okay, yep. Now I actually feel like I really know it. So, it's how you make a Decepticon. All right, so anyway, I completely missed Just As Good Joe answering the question I actually did ask, which was perfect. Class imbalance, exactly. So whenever we're going to do a classification task, and that's how we're going to approach sentiment analysis today, is as a classification task, we need to have class balance. If we want something to predict, membership in a class, we need to have similar enough examples of each of those classes, or we risk overfitting to one of the classes. And that's something that we saw. If you're interested in learning more about that and what happens, I would say go back to the classification stream, because we learned a lot about class balance there, and also the logistic regression stream. So both of those we dealt with problems related to class imbalance. Now my notes are over here now. Oh, it's going to be confusing. I'll deal with it. Okay. So what do these tweets look like? Sorry, I literally just I looked at only the positive tweets when I was prepping this, and so I just was like, I'm curious. What does one of the negative tweets look like? And it's like, oh God. Oh man. All right, well that's how we're starting it off. That's the year so far. So thanks, negative tweets, index 0. Hits a little too close to home, friends. All right. And oh no, yeah, I know all the 40 exactly 2021 in one string. No, we can't look at it. Go away. All right, well, I feel like comparing these two, one of these is way more negative than the other one. Like, this is, I guess, negative, but it's not so bad. In any case, let's see here. So we are going to use a tokenizer. This one is specifically for tweets, because this is going to be very, very useful. You wonder what's in negative tweets 2020? All right, this is for you, creative one. What about 2021? These ones I don't understand, but there you go. Doom scrolling in Python? No, I refuse. Damn it, I feel called out. No. All right. Okay, so tokenizing. I'm going to say Exegeticus, you're not allowed to answer because you are very well versed in NLP, but someone remind us, what are we doing when we're tokenizing these tweets? Do this while I set up this class. We don't care about case. We're going to strip the handles, which is going to be very useful. So handles are just what the Twitter names are, usernames. All right. So let's see. What classifies a tweet negative or positive? Is it supervised by a human? In this case, I believe this is a human labeled data set. So we are going to actually, what we're doing tonight is we're going to build a sentiment analyzer that is going to, based on training and testing on this data, and then we will do some validation. So I'm going to go to Twitter. So y'all get to see a picture of a little bit of my Twitter feed. I'm going to go to Twitter. We'll grab some real tweets and feed them to our sentiment analyzer and see how accurate it is. We're turning them into unique tokens. What do you mean by that, Ori Concept Arts? And yes, Lovebone, you're right. That is sentiment analysis. That's what we're gonna do tonight. But when we tokenize, when I'm gonna feed this tweet tokenizer a string that is our tweet, what's it gonna do? What do you anticipate it's gonna do? And it's cool if you don't know. But if I say feed it tweet tokenizer tokenize method, and we're going to feed it, let's say, a positive tweet this time, what do we anticipate this is going to do? And let's see. You did get one right. Good job. And is this the Jupyter Notebook? This is. And let's see. Apple 2 Games, you say sentiment analyzer, Twitter negative, more negative, really nasty negative. You know, I find that Twitter, like any kind of aggregator of content, is very sensitive to, you know, what you choose to do with it. So you can make Twitter a much better place through things like, you know, being strict about who you follow, blockchain, whatnot. But I don't know. I've worked quite a bit on pruning my Twitter feed. And let's see, Alt-F4, you say you could use this for Quirk for your sentiment moderation. Yeah, I mean, so I would not use this exact model. I'm doing a very basic one tonight, but sentiment analysis, there's a lot that you can do with that. And so let's see. Ori Concept Arts, you think it would turn it into a token ring list where each token points to the next and back? Not quite. So this is a little bit simpler. Positive tweets with an S. It breaks it down, because remember I said earlier that tokenizing is the process of breaking down our text into subcomponents called tokens. In this case, we're going to feed in our tweet, and it's going to spit back to us words. So we've got a couple things that we need to do with this, though. So first of all, we have things like engaged, past tense, and members, plural. And if we're really wanting to kind of strip things down to the bare bones, what do we need to do? What do we call that? Where we got to like get out, you know, we want to find out the base word here. And I'll set up, hold on. While you are answering this, I will set this up. Should work. And then, yes, exactly. Standard error, you got it. Lemmatization. So for our lemmatization, though, if you remember what I said earlier, our lemmatization requires a token, and it also requires a part of speech. So the role that word is playing in the sentence. So we're gonna get pause tag, which is, it generates tags that are the part of speech for the token that we feed it. So first, we are going to tweet tokenizer. Okay, so all I did was I made a list of lists where each of our lists here is the token list for the tweet. Okay, so that's all we did. We just converted this to a list of lists and processed all of our positive tweets. So we should also probably do this for our negative tweets. So let's see here. We must tweet the tweeter with the tweets. I know. Oh, Twitter with tweets and what is tweeted? But I want it to be twote. I think that'd be hilarious if that was the past tense of tweet. In any case, a warbear, you say, I wonder how this works in Finnish, where you have massive amounts of compound words. That would be very interesting. So when we work on like removing stop words, for example, we are going to feed it. We're going to feed it the stop word English dictionary. But one of the cool things with lemmatization is that lemmatization works off more complex rules based on the language's grammar. And so I feel like that would be a much better approach for something that is a more complicated language for sure. Okay, we have our positive tokens. We have our negative tokens. So what does it look like if we do this pause tag business and we feed it, I don't know, let's say, somebody give me a number between 0 and 5,000. 3857. You got it just as good, Joe. 3857. So, oh my God. What just happened? Okay, well, do not fear, because somewhere I saved the guide, because I only know a couple of these. There it is. Oh, thank goodness. All right, so look at what I have for all of you. There we go. So, because there's no way I don't think any of us are going to remember all of this. Maybe if this is what you do every day. But, so NN is noun. I believe in this case, NNS is standard noun. So it thinks hi as a noun. I'm just going to move this stuff for you real quick. And thank you, Enigma Dev, for resubscribing. Thank you, and welcome. It's good to see you here. You're on a 2-month streak. Oh, yeah. Stream support. So foreign word. I like that. Existential. That's cool. So let's see. What do we got here? We got RB, which is adverb. Sure. RB is adverb. So usually there are like 2 letters and then a modifier. So NN is noun. NNS, noun. Wait a second. Oh, come on. NNS is plural, not singular. Okay, whatever. So you can also see, it looks like PR is pronoun. VB is verb with various modifiers at the end. We've got JJ, which is adjective, sure, for reasons. I was curious, this is personal pronoun. Possessive pronoun. Okay, yep, that would make sense. And we've got all of these wonderful things, which is helpful. So this is how our part of speech tagging works. We're not going to be overly concerned with memorizing all of this unless you want to go off and be, NLP every day, which if that's your jam, I would say go for it. But does it do it using a dictionary search? So I think this is more context dependent actually, because a dictionary search you might have one word that could have multiple roles, and doing a dictionary search wouldn't be enough. So, let's see here. But we have some problems. What are some problems here? What are the problem that you see here with our little pause tag? There's some issues. Oh no, did we lose our music? Already? Has it really been another 45 minutes? One sec. Where'd it go? Where's my music? Oh no. We need our holiday music. Where did it go? Oh, there it is. Can you tell I have way too many tabs open? And so Matisse Tech, what's interesting about the library is that it doesn't have a dictionary of tokens. It's not just like taking the token and looking it up in a dictionary. That would be so laborious. So it's actually able, if we were to feed it groffling, right? It would be able to infer groffling is probably, made from the verb groffle. So it's doing this based on word patterns and inference. And virtual assistants, it's okay that I isn't capitalized. So I actually set that when I imported when I tokenized each of the tweets, I actually set it to remove case. That's often something you want to do so that the computer can recognize a tweet that has a singular I and a capitalized I. It's the same word. And Sebasti, 1959, thank you for following. And where could I say tu parles français? Je parle un peu de français. I don't get enough chance to practice. Je n'ai pas beaucoup des opportunités de pratiquer mes français. And so, yeah, the website was considered a noun, right? So maybe we want to be stripping out URLs. That's not helpful. And so there's a couple things we need to strip out. We don't want things like commas in there. Like, it doesn't need to be sitting here trying to figure out what a comma is. What's interesting is also emojis, because my first attempt through this, when I was prepping this for stream, I was like, like blah, blah, blah. I stripped out all the emojis because, like, nobody wants emojis. And I got like a 74 to 76% accuracy. And I was like, And then I thought back to like my tweets and my texts and things like that. And I was like, I use a lot of emojis. And so I was like, let me just put them back in. I put them back in and the accuracy went quite up. So I think Just As Good Joe, you mentioned earlier, I think it was you, who said it might be training on the emojis. Well, I've fed it plenty of tweets that don't have emojis and it seemed to do just fine. But I think emojis can be a very strong indication of, very, very strong indication of sentiment. And so we should definitely keep them in. So I learned that the hard way. And you say 76 is low, but be careful that the beautifully cleaned, well-balanced data sets that I show you designed for machine learning aren't spoiling you. You cannot expect like 99% accuracy from everything on every data set. Like that just, I think I've tried to emphasize in all of my streams that the data I show you is not representative of the real world. I'm showing you patterns and how to use strategies, but the results you get are because these data sets are designed for these tasks. So when we use real world data, which actually, again, I'm kind of sad that MC Childs isn't in chat because he and I are going to be working on a machine learning project using data from Twitter, real Twitter data. And so I'll keep you posted on how the accuracy of that goes. Where did my notes go? What are we doing next? So yes, we understand. All right, we've got these list of tuples where our token and our part of speech. And so we need now to lemmatize. We need our lemmas. And oh yeah, no, virtual assistant, by all means, go for it. So I definitely am very much recognizing there are lots of different strategies in AI. I would encourage those of you in chat who are more familiar with machine learning to remember that this was my introductory sequence of streams for machine learning. So I'm trying as much as possible to not talk over people, to not throw at you, the most bi-directional transformer stack where you all are like, what even is happening? So we are going to use simpler approaches so that there's a common knowledge amongst all of us then that we can use later. And DB Apple, thank you for following. And Sebasti, you asked me how old I am. I will be 30 in March. And Stannis for King, you asked how my parents are doing. My parents are doing all right. It's hard. I think my middle brother who lives with them is very, very, he's very worried. And he can be very emotional. And so it's hard for me to kind of parse from what he's saying what like the medical facts are. So I've dropped off my pulse oximeter, and I am having him check fevers and pulse oximetry with a regular enough basis that if the numbers change drastically, I will be concerned. And that's my facts, my sanity check. And hi, Wolf18, welcome. And so Apple II Games, you say, does this also pull out entities? Well, entities are largely, right, they're going to be proper nouns. This does pull out proper nouns. So he can be love phone. All right, so we need our lematizer. So, thank you, library. We're gonna use their WordNet lematizer because I've had good luck with it. So let's instantiate it. All right, 69 viewers, nice. Well, I'm trying to get better about not looking at the number of viewers. I'm trying so hard. I'm really bad at it though. So what we're gonna do is let's simplify a little bit, because we're gonna take this complicated, NN, CC, personal pronoun, whatever, and we're going to simplify it, okay? And this is just going to be, now this could be an area where we could improve our model, but also our lematizer is going to take verb, noun, or adjective / adverb. And so we're going to feed it those particular tags. And let's see here. So, no, I want to remove this so I can see above. There we go. All right, so let's define. We're going to call it lematize. Let's make sure. Why did I do that? I called it the same thing. Lemmatization is what we're going to call ours. Jess, oh my God. Calling it the exact same. No, I'm fine. I can call this lemmatized. That's fine. All right. Anyway, so we're going to feed it a list of tokens. It's going to be a list. And what I would like it to give back to me is I would like it to give back a list of the lemmatized tokens. And let's see. Apple II Games, you say, and since you're doing this on your own machine, it's going to be a heck of a lot cheaper. Absolutely. So there have been people asking me like, oh, like, why aren't you using, AWS or whatever? And for the models I'm showing you and the data sets I'm showing you, you don't need to go out and buy like fancy time on GPUs or whatever. Like you don't need that. Everything in this series of streams is designed to be run on like a laptop. So should be very basic. You might like run something and it might take a little bit of time. That's fine. But I want as many people as possible to be able to use and run this code. So maybe when we do some of our really complicated, deep learning, whatever, we'll talk about, we'll see. If we need to get some fancier compute, we can get some fancier compute. But for now, at least, I'd like to keep it as accessible as possible. Okay. Another streamer crashed in science and tech. They're coming after us. Oh no! What? Oh God! Is it just? Well, I mean, I pretty much only watch science and tech people. So I don't know if any of you are watching people who do games, if they're having problems too. Please stream. Stay with me. Don't leave me. Please. We have so much fun to do. Don't leave me behind. Okay, so when we're lemmatizing, like I said, we're gonna want it to give us back a list of lemmatized tokens. All right. And so just like we saw when we looked at our pause tag method, right, that we are getting, it gives us back a token and it gives us back the tag, right? So, hi Hamster Hammer, welcome. So in this case, we're going to say, okay, for each token and tag that we get when we call that pause tag method on our token list, if our tag starts with VB, right, which is our verb thing, we are going to say it's part of speech is a verb. If, Let's see. Full Stack Overflow. Thank you. Thank you for following. I still need to get my Snack Overflow sticker. So I'm really excited because I really, really, really love this artist. Let me get her thing. Kelly Mahoney. It's like So Splush. I think it's her Etsy. Hold on. So Splush. There it is. So she is, I absolutely love her stickers. I'm not usually one to be like into cutesy things. That's not really my aesthetic or whatnot, but like I just love her stuff so much. And she has a sticker, which is this giant thing of cookies, and it says Snack Overflow, and I want it. I want it so bad. And there's also Full Stack Developer, which if I was a full stack developer, I would really, really want them. She also has Pokeballs that are designed to be the emblems of different programming languages because you got to catch them all. I love it so much. I want all the things. So she was designing a series of stickers for the various Sailor Scouts and Sailor Moon, which is something I grew up with and loved and still love very dearly. And I started communicating with her about the colorization for my favorite Sailor Scout. And I was kind of giving her a recommendation. And so as a thank you, she sent me the sticker. Look at this. Look at this cuteness. And she also sent me this. Strofium's not in chat, but I thought he would also appreciate this. She sent me this as well. I don't use sass, but it's a little hot sauce. It's so cute. It's so cute. So you should definitely, if you like her stickers, give her some love. I really like her shop. I love her designs. So she's awesome. Okay. So let's see what else we're doing. Tag starts with. I actually don't know if she makes pins. I would love for her to design some emotes for the stream, so I need to save up for that. But I'm not sure about pins. I know they have Tuxedo Mask, right? Oh my god, I love her Etsy so much. There's such cute things. Really quick, we're just gonna look very briefly. I just love this like YOLO. I love it. I love it so much. Oh, where's the Afraid to Commit one? That one is also really, really, yeah, Afraid to Commit. And there's the Snack Overflow sticker. I love it so much. Coding by Moon. Okay, that's awesome. That's also a Sailor Moon reference. Max and cheese. So lots of cool stickers that I just think are absolutely adorable. Definitely need the This Is Fine, though. That sums up way too much of my development experience. But, and so let's see here. Apple II Games. I'm sorry, I thought I put it in stream. I might have forgotten. That is the Etsy, so feel free to peruse it. And it's wonderful. And Alda, for you say Tuxedo Mask is literally your childhood hero. But like, I love that meme that's like him with his cloak, and it's like, I forget what he says. And then Sailor Moon's like looking up and she's like, but you didn't do anything. Like, my work here is done. Yeah, he's like, my work here is done. He's got his cloak. And she looks over and she's like, you didn't really do anything. Because he just like swept in to be like kind of romantic with a rose and just like swooped back out and left her to always do the dirty work. Okay, well, he is pretty. Yoko Rosa, thank you for following. Okay, so back to natural language processing. All right, so we are converting our more complicated tags here to simple parts of speech, basically verbs, nouns, adjectives, adverbs. And let's see, for each token and tag, then we will, once we have converted it into a way that our lematizer will understand, we can feed our, oh my gosh, come on. We can feed our token and our part of speech to our lematizer, and it will lematize for us. And then we're going to return with 2 M's, our lemmatized tokens. Okay, fancy dancy. I don't know why. I think I just made a bunch of like random new lines. Okay. Pretty doesn't fix being a dick. Oh my god. I mean, if we're going to have a Sailor Moon moment, first of all, Sailor Moon herself was the most aggravating part of that series entirely, which is why when you see them later in their life, when they're like the prince and princess or whatever, she's the queen, then they're like a lot more likable because they're like mature. There was some like icky age difference, I think, also between them, but that's why Sailor Mercury's the best. She was the like nerd. I loved it. Wait, you thought Sailor Moon is a character? You thought that was their boat? What do you think Oh, yes. Okay. I played this game with Loafbone once, which is like, he didn't know anything about Pokemon. So I just started having him. One of the redemptions used to be, you could ask Loafbone to draw a Pokemon. And because he doesn't know any of the Pokemon, it would end up just being what he thought the Pokemon looked like. It was hysterical. So what do you think Sailor Moon is about, Loafbone? Oh, I'm so ready for this. It's going to be hysterical. What do you actually think it's about? And Images and Airmen, yeah, so there was an anime that was based on the manga. I liked both. And yeah, Mediocre Gamer, there's a redemption, which is Loafbone draws something. So it's about space ladies who are all gay and sail around fighting crime in their space boat. I love it so much. I mean, the thing that made me very sad is there actually was a gay relationship canonically in the manga, but when they and in the anime, but when they ported it to, or they like translated or whatever, dubbed it to America, they dropped it and they made them cousins, which made like some really, really awkward like interactions where they just seemed like a little too into each other, but they were cousins apparently. And they like live with each other and like raise a kid, so whatever. Anyway, the manga gets spicy. It does. It's very good. Okay. So let's take a look at what our lematize function looks like. So if we look at our positive tokens and we look at our lemmatized positive tokens, it happens when I speak out loud. And Harry Brown 98, thank you for following. Better to be cousins. Well, at least I guess that was their that was the 90s in the United States. So, and Thomas Eckert, thank you for following. Mediocre Gamer asked me, is there a Sailor Pluto? Absolutely. She is like the guardian of time. So she's got this awesome like giant staff with like the key, and it's like the key to the doors of time or something like that, and she can control time. So, Devil Shoots Devil, thank you for following. See, those of you who are cranky that we were talking about Sailor Moon for a second, my followers here, they know what's up. Can't be gay if you're related. Big facts. Oh God. Well, I think that's also maybe something that slipped by my parents a little bit, which was they got me the manga as a kid after like watching the anime with me for a little bit. They're like, yeah, this has good values. And then the manga's like got a lot of like implied nudity and probably explicit nudity, like more implied. Is definitely like outright spells out like the gay relationships, awesome queer relationships, and also in the later series there's also some trans Sailor Scouts as well. So it's awesome. But I think they didn't realize it because they'd watched like the anime with me, so they let me read the manga, and like little childhood Jess was like, the world is an awesome place. But Diet Coke Wolster, see, Appleton Games, I'm so glad I'm able to give Kelly Mahoney a shout out. Hold on, I'm gonna actually like tweet at her real quick because she's really, really cool. Stream has devolved into So Splush fangirling. She's seriously, I love her designs. I love her everything. She's got such a good approach to like this, the tongue-in-cheek wit and puns like I wish I had, and then really, really cool design for stuff. So, our music isn't chiptune tonight. It's holiday music. I must have forgotten to change the Nightbot. And let's see here. Automod hates you. It's okay to be a lot of gay all the time. Also, yes. Oh, you're placing an order now. Yay, Apple II games. Awesome. Yeah, it's Sailor Moon is awesome. Kelly Mahoney's also awesome. So good stuff. Good stuff. I love this. This is so cute. Sailors Who Code. Okay. All right. Gotta calm down. I usually don't like cutesy things. Like if you even look at my work laptop, just attached to a bunch of things. So hold please. Like my stuff isn't super cutesy. So I've got Star Trek. Obviously, I've got, let's see what else. So that's the Starfleet Academy. This is the SG-1 sticker. This is Vulcan. I forget what this is. I just thought it looked cool. This is something for work. I have the future is female and consent matters sticker and my I voted sticker for in November or October, whatever. November, obviously. And then this is like an astrophysics sticker. So I want to save my Sailors Who Code sticker for something really special because I don't want to stick it on my work laptop because eventually I do have to give that back. But in any case, Sailor Moon is awesome. You all should check it out and also check out Kelly Mahoney. So she's got excellent stickers and probably other stuff, but I always just get stuck on the sticker page and start trying to buy everything. So stick it on your face and never remove it. You'll have it forever. Well, that is one approach. A tattoo. Well, that like you have to be careful with artists. Like you want to respect. You would have to like be able to get permission or whatever, right? So, okay. Let's see here. What even were we doing? We're doing NLP, right? I got so distracted by cool stickers. Okay. 99% of your clothes are older than your dog. What? Let's see here. So, okay. Lematize. Positive tokens. This is what it looks like. So we have, you can see that members has turned to member. Engaged has turned to engaged. Being has turned to be. So this is our lemmatization process. And habanero. Thank you for following. Okay, so let's see here. Oh no, all of my tabs are suddenly out of order. Hold on, friends. I've got a system. I got distracted by all of the awesome stickers. Okay, and MH Zaneraman, you said hydrate. Cheers, friend. Okie doke. All right, so one of the things that we're going to need to do next is we're going to need to clean this data. And so cleaning might be removing words that we think will be less important. So words, especially like, think about our task here. We're interested in sentiment analysis. And so we want to remove words that probably in this case won't be as helpful, right? So our stop words, remember that is something that we talked about previously. And oh my goodness, hi. Okay, yes. How are you? Sorry, 1HDC1. You say your Silvestri codes from Twitter. Yes, awesome. Hi. You have the most excellent selfie game. It's amazing, seriously. And also, like, aesthetic. I think you had like some galaxy print or star print leggings the other day, and I was just like, I need this in my life. Okay, and so infinite star code, you say maybe a shared Google Labs notebook could be helpful. I actually haven't done Google Labs notebooks before, so I'll look into that. And lemon sauce, thank you for following. I think did you send me the link to them? Or were those the ones that were out of stock? They might have been, there was something else that was really cute and you said it was out of stock. But also, I'm so glad I was able to send you Startorialist. So if anyone is interested, by the way, in space-themed apparel, a friend of mine from the astrophysics community started a company called Startorialist, which again, everyone is wittier than me. I don't know how people do it. The pun game is just... And it's all space-themed clothes. So everything from like kids stuff to cool hoodies and shoes and all kinds of things. Yes, I will post the link. Hold please, Startorialist. And if I could just have a hipster moment of I was in before it was cool, I was a huge fan of theirs right when they first started. And it was just a booth at the American Astronomical Society conference every year. But now, oh my God, they have this cool website. Oh, I'm out of James Webb's face mask. Also, I don't know about any of you, but I was in the car yesterday or today. It's been a long day. And I just like saw all of like the hanging masks on my, I have like a thing on my dashboard. And it was just this moment of like literally, what? It's like my N95 for fire station stuff and like all of the masks and everything. And it was like, man, what a year, right? Whew. Wait, which tattoo are you talking? Or wait, Third Tier Gaming. Yeah, I think you posted it in the Discord, right? If I remember right. You had a cool space tattoo. I'm forgetting which one it is, but. And Stannis for a King, you ask, is it out of this world? Yes, it is out of this world. Actually, no, I'm not a very big jewelry person. I wear like earrings and stuff for stream a lot of times because it seems to add just like something, I don't know. But one of my favorite pairs of earrings that I actually do love is a 3D printed Hubble Space Telescope. So they've got awesome stuff. All right. And Harry Brown, 98, you ask if I have a background in physics. My background is astrophysics, actually. So, oh yeah, and I'm 100% okay with wearing masks. Like, we should also just normalize that for when people get sick. Like, if you have a bit of a sniffle or a cold, like, just wear a mask. Keep the people around you safe. Like, but given how America's reacted to wearing masks for a disease that's killing hundreds of thousands of people, I don't know if we'll get people to do it for the seasonal flu or cold. And no worries. No. It's okay. It's okay. Don't worry about derailing me. We were on a derailment previously for my love of everything that Kelly Mahoney like creates. So I don't know if you know her stuff, but I was putting her Etsy. I think it is something that's like right up your alley, honestly. But everything this woman creates, she's an amazing artist, and I love her design. I want it all. I want all the stickers. I will become a sticker. It will be awesome. Okay. Most streams are a bit wandery. Yeah, so there's always like a middle chunk where I think we get off topic for a little bit, so I'll tell stories about my grandpa or stories about my dogs, or there's questions about space, and then we kind of come back to the task at hand. So I don't want this to feel like a formal class. And Van Farrock the Lord, thank you for following. I don't want it to feel like a class. So I don't want you all to feel like you're sitting here like, I must take notes and like, we cannot go off topic. This is a casual conversation amongst friends with code and math proofs. I don't know what friends you have, but those are part of my casual friend conversations. Let's see here. So yes, we were talking about stop words. So, oh no, I already downloaded this. I don't need to download this again. Let's note to myself to download it, and I did. Corpus. We are going to get our stop words, our filler words. We want to remove these. And Oozman TK, thank you for following. Now, what might be, and I'm sure those of you who have done, NLP before are going to know this, but like, what might be a case where we don't want to remove stop words? In our sentiment analysis case, it kind of makes sense. Let's get rid of it. Let's remove some of the noise from our data set. But there might be cases where you want to leave the stop words in. And what might those cases be? So you literally started a convo with me about black holes. I know. Yes. That was excellent. I'm sorry. I think I also failed to respond at some point. I'm absolute shit with Twitter messages. Also, I'm at the point now where work has Slack, Teams, WebEx, my email. Then there's also various other like non-work Slack channels I'm in. I've got Discord. I've got Hangouts. I've got texting. I've got 3 email accounts, which are like my Fire Station email, my personal email, my professional email. At a certain point, there's always like, I just get so tired of having to check everything and make sure I'm responding. So I'm sorry. I'm the worst at messages. So MH Zinnerman, this wouldn't remove theory. So it's not doing, if you're thinking about this from a programming perspective, this isn't going like, is this word in, right? So it would drop, in that case, it would drop theory because the is in theory. This is just dropping the token, the. So why might we want to keep them? Oh no. Okay, there we go. Why might we want to keep our stop words in? Or do we always want to remove them? Is that the case? The Rings of Saturn skirt. Ooh, I haven't seen that, but that sounds awesome. Okay, so one time where we might want to keep stop words in is if we're working on text generation, perhaps. So if we want to train on producing accurate representations, like a chat bot or something, we want to train on actual human language. If we remove all the stop words, it's going to sound really weird. We need to also sometimes be able to show our NLP models what authentic language looks like. Proximity of words, that's another great point. Beyond here lies nothing. And, oh yeah, so standard error, thank you for pointing out your comment. So you also say, like, in the example, the letter A is a filler word. If that was our sentence, if we tried to drop A, that wouldn't make sense at all. Like, that suddenly that sentence is nonsensical. Glow-in-the-dark constellation legacy. No, I will focus. And third tier gaming, you ask about sartorialist being women's clothes. So it started out actually as a poster at a science conference that my friend did. Summer Ash, you can look her up. She's really cool. And she and her collaborators were studying like how femme people in astronomy were kind of showing, like kind of saying like how to put it, like tagging themselves as astronomers kind of through their fashion. And so also kind of like making space for more femme people in astrophysics. And it's blossomed because people were like, oh my gosh, you know, this is really cool. Like we all kind of want space themed things. And so it's blossomed more and more into a collection of clothes, but it did start looking at more femme people. And Cougar Rex, you say, thankfully you have dual monitors and can watch this in a SpaceX launch. Awesome. Well, let's see here. So we need to also specify, as I said earlier, stop words are not the same across all languages. So we need to specify what language we're using. So stop words, in this case, is going to be our list. We're looking at English tweets for now. So if we want to go off and we want to do some French or some Arabic, we will have to change this. But for now, we're going to look at English tweets. Okay. So we need to clean our data. So we need to not only remove stop words, but we need to remove if somebody is tagging another user, because we're not doing network stuff today. We're just looking at meaning and sentiment. Also, if there's a URL. And also, at least for now, let's remove hashtags as well. So happy, sad, or important. We will not remove those. No, we're not talking about Elon Musk. Nope. We're not going to do that. So let's clean our data instead. We need our list of tokens. We're going to need our list of stop words as well. And what we are hoping to return is a list of cleaned tokens. So the way that I did this, at least, is that I thought about it like this. There's going to be characters that mean that the token to which they are attached needs to be removed. So that would be like the @ symbol, for example, because in Twitter, the @ symbol goes with a username, and that's something that we would want to remove completely. Then there's going to be characters that we're going to want to remove that we don't want to remove the whole token, we just want to strip it from the token. And so for those, I made a trim characters list. And things I included here were, I guess I did include, that there. Well, that was a stupid mistake. Well, you can't see my notes, so you don't see the stupid mistake. All right, so we're also going to move things like periods, I wish, commas, asterisks, however you say it, and symbols. We're going to remove percents. We're going to remove $signs, question marks, and quotations. That's it for the Elon. Thank you, Lofa. So let's see here. Trim characters. All right, and then we have the remove characters. And these are where we want to remove the whole token if these characters are present in the token. And so that's going to be things like the @ symbol, like I said, for Twitter. We're going to move hashtags and also for URLs. Okay, and then we also need a list, actually, of our cleaned tokens. And this is what we're going to return. So what do we need to do here? We need to go, we're passing it a list of tokens, so we need to look at each token in our token list. And then we need to check, are any of the characters that are in our trim characters or our remove characters present in our token? So for that, for each character in our trim characters list, let's ask it, if that character is in our token. Oh my God, I'm starting to type what I'm saying instead of typing the code. Woof. If that character is in our token, then for our trim characters, we just want to remove that character. We don't want to remove the entire token. So for that, we're going to use strip. So we're going to strip out that character. Just means remove the character. Also, for the characters that are in our remove characters, if our character is in our token, we are just going to set the token to be nothing, like that. Okay, so that would remove characters that are in the trim character list. And if a token contains a character that's in remove characters, it'll remove the token entirely. So now we need to check. So if the length of our token, the number of characters, is greater than 0, so aka it's not one of the remove characters, and our token is not in our stop words list, then we'll add it. Okay, and after we've done all of that, we will return our cleaned tokens. So let's see what this looks like. So we've got our, let's see, we'll say this is our test case. Else clean data, yep. Test list, and then our stop words. So here we go. So I will say this, like I said, I actually added the emoji, like various emoji components to the trim characters list, but we actually want them. So now we've removed follow Friday, we've removed the stop words, And this is kind of the output. This is how we've condensed that whole tweet that we saw originally, which was a positive tweet 0, I believe. This. We've condensed this longer tweet into a smaller list of tokens that have been lemmatized. So that is our data cleaning process for now. And Nico Solar, thank you for following. Okay, so now that we have cleaned our data, and Isaac Dev, thank you for following. Oh, there we go. We also need to prepare our data because the models that we're going to use tonight take on certain, they need our data to be in a certain format. And Nico Solar say, hi, this looks super interesting. Good for you for learning the things. I am teaching the things tonight. You're learning the things, but I am all about learning the things. But I'm hoping that all of you are more learning the things. Okay, so let's see. We need to prepare our data, like I said. So the models that we're going to use tonight, and we'll go through them, and I'm going to teach you all about them, so don't worry. But the models we're going to use tonight kind of need our tokens and everything to be in a certain format. So we're going to have a couple of functions that we're going to use to do that. So first, let's get all of our tokens, right? So that's going to be our list, and we're going to have stop words, which is also a list. And so in this case, we're going to have a clean data. We're going to clean all the data. So for each token list, because remember our all tokens are going to be lists of lists. So in this case, for each list of tokens that we have in all the tokens, we need to clean our token. We're going to get our clean tokens first. Then we're going to lemmatize it. And then we will append our list of cleaned tokens to our cleaned data. And then we're going to return that clean data. Okay. So now, if we want to look at it, we can say our positive cleaned tokens are going to be we're going to prepare our data here. We're going to feed it our positive tokens and our stop words. And we should, if I did this right, oh my lord, not have that. Stop. Well, fair enough. We have our nice cleaned output. And so we also, in this case, have all of our tweets have been cleaned. So our data is getting ready here. So we also want our negative cleaned. I think I already did our negative tokens. I think we already tokenized our negative tweets. Okay, good. We're all set there. And let's see. Ooh, ties. I know, I love ties. I love wearing ties. Okay. So part of that data prep, part of our getting things ready for our model is we need to do a couple of conversions because it's going to, I'm trying to remember, and it needs everything in a list of dictionaries, I believe. So we're first going to need to convert what we have to dictionaries. And Foamy93, this is Python. So we're not using C or C# or C++, so we don't have the semicolons. And so for each of our token lists that's in all the tokens, we are going to yield a dictionary that is going to have this form. We're going to have token, comma, true. This is the model specification. So this isn't just some fancy way to do it. This is what the model is expecting. So we need to get our data into a format that the model will accept. And as a test, we'll call it thing because I already have something called test. Oh yeah, this is a generator, that's right. Then we'll look at that in a second, actually. Icky Sticky Bandit, thank you for following. So then, okay, we're almost there. I know this is the like slightly less interesting part because we just have to get that data ready. So in this case, we're gonna need our positive tokens, which will be a list. We're gonna need our negative tokens, which is also gonna be a list. And don't think I need anything else there. And we are gonna get back a list. Okay. So in this case, we're gonna need our positive tweets, as we'll call it, are gonna be, again, it wants a dictionary. Oh yeah, it's a tuple. It's a tuple of a dictionary with the label. So this is more of a supervised classification. And beyond here lies nothing. Thank you for following. Okay. For positive dictionary in our convert to dict, and I need to feed that positive tokens. Okay, and same thing for our negative tweets. Got two lists of tuples of dictionaries. I can't tell you how long it took me to make sure everything was perfectly right and the errors I got for this model. So all right. Oh no, we lost our music again. Has it really been that long? I feel like the music's just going away way faster than normal. It's just time flies when you're having fun, right? Okay, so now we have our data set. We're going to prepare our data for the model. We are going to give it our cleaned data, right? Because we want to use our cleaned data. All right, so what does this data look like? This is what it looks like. So you have a true for if that, I think that is just an indication for if that particular token exists in this tweet, and then the tag, which is positive. So let's see here. Now we do have a problem, which is that given the fact that we processed these separately and we just added them together, right now our data is sorted by tag, and it's sorted by our label. So all our positive ones are going to come first. All our negative ones are going to come after. So we need to shuffle our data. Okie doke. So now it will be shuffled. It will be in a random order, and we are ready to make our train test split. And so for this, I'm going to do a 30-70 split. So that's all I'm doing here is I'm saying this, and our test is going to be yes. Okay. So now we've got our train and test data. Eclipse X and Matnesis and Bamadi Sharif, thank you for following. Okay. And Pierre Claver, you say you actually like it better without the music. You can focus on what I'm teaching. I actually frequently don't have any music during stream, but for the 12 days of machine learning miss, you got to celebrate the holiday theme. So I got us some don't worry YouTube, it is copyright and DMCA free holiday music. All right. So before we move on to what kind of model we're going to use, before we build that model, we're going to have to pause for a second and go back to our whiteboard so we can learn about what this model is going to be, because this is going to introduce some stuff that I've never talked to you about on stream before. So give me a second here. Okay. we will move this here. Okie doke. And train and test won't be the same. So I shuffled it, and then train will be 70% of that data, and then test will be the remaining 30%. Okay. You know, Harry Brown, like when I don't, it's a YouTube channel, but like it's just a dumping ground for VODs from Twitch for me right now. And I was so irritated because I had like 3 people following me or subscribing or whatever you call it on YouTube. And I got like a DMCA thing. And I was like, are you kidding me? So I had to like fill out all this stuff and basically show with like screenshots and like links to it. I was like, literally, this is a list of DMCA free music. Like, here are the conditions for using it. I meet those conditions. Like, and oh, lo and behold, like several weeks later, whoever it was released their copyright. And it wasn't even accurate. Like, it wasn't even the place where I had gotten the music from. So it was just, Anyway. Yes, I did type 0.3 in both lines because the way that Python does indexing, right? So we have index, we have our start and our finish, right? So in the first one, our training data, it's everything up until the last 0.3. And in the other one, it's that last 0.3 to the end. So converting this to an index and indexing like that. So it actually will be different. Okay. So, yep, no worries, standard error. Like, also it's hard when the code is live and you're watching it on, you know, a monitor. That can be tougher. So, Third Tier Gaming, you just spent $60 on space stuff. Nice. Excellent job. And Trickster, you say, hello, this is neat. Well, welcome. And Krieger Source Rex, you want a quick whiteboard recap. So we didn't do a lot of whiteboard today, especially compared to other days. What we did do is we talked about possible uses for natural language processing. So why, in the first place, we even care. Then we talked about challenges, like specifically when we're working with high volume, unstructured data, what are some of the challenges? I talked about some of the approaches and strategies that we can use. So this is where we talked about part of speech tagging, or at least we talked about stemming and lemmatization, tokenization. These are things that we just used, stop word removal. Then I like kind of formally defined some terms for us. So corpus, things that we're not going to use today, at least not right now, bag of words, n-grams. But this is where we more formally defined stemming and lemmatization and also vectorization. And I gave a simple example of how you might vectorize text input with a count vectorizer. So, okay. You honestly, like the vast majority of this is going to be code versus Blackboard. Because I think last time, we've had a few Blackboard heavy streams, so I wanted a more code heavy stream. Okay, so the model that we're going to use today. Do I have my space themed pen? Yes, I do. Okay. It's called Naive Bayes. What? I know, that sounds weird. And especially when I've taught this to other people, there's kind of that moment of like, naive, we associate like it's a bad word, I guess. So we want really not naive models, intuitively at least, right? Because naive sounds like the model's like ignorant or something. So don't worry, we're going to talk about it. Don't leave. But Naive Bayes is actually a really popular classification model because it's very easy to tune it. It has good performance. It's got very low storage and time complexity. So it's good. It's very commonly used, especially when teaching kind of basic. Well, in basic classification, I would say there's even more simple approaches, but it's often taught with classification and also with NLP. So I know, I love Bayes too. So we haven't talked about what Bayes is on stream before. And so I know we've done some probabilistic stuff in previous streams, but we haven't really talked about Bayes' theorem. And that's right. The Bayes here, not Bay as in before all else or little, like this is not Bay, but maybe Bayes is Bay if you really like Bayesian statistics. But Bayes' theorem And oh goodness, I have to click off this to see. Amen break. Thank you for the follow. All right. So this is just another way that we can approach probability. So we've talked about, when we were talking about picking marbles out of a bag or drawing cards, we were talking about like the number of times this might happen versus the number of times other things happen, the number of times, the frequency with which things happen. Frequentist statistics is what we've been doing. And you can just remember that if that helps. Frequentist, frequency, the amount of times something happens. So whenever we're kind of doing the basic probabilities we've done before, we've been using frequentist statistics. And oh yeah, so you need to catch my streams more often. Yay! I occasionally have moments of intelligence. Okay. Bayes is going to be a little bit of a different approach. So before we even touch what Bayes' theorem is, let's start considering some notation so that we don't get lost, right? And also some concepts. So you've seen me write stuff like this before, right? The probability of A. So this is just the probability of event A, of thing A, right? But we're gonna make a little additional kind of add-on here, right? Which is that it's not just the probability that an event happens. We're also just like, let's be explicit, we're not considering anything other than A. So we're not considering other events or other outcomes. Okay. Now, we've also talked about the probability of A and B. So B, A, and B. And this is, I should probably give you the fancy word for this. Hold on. Hang on. Don't go anywhere. There we go. Talking both to you all and the whiteboard. So this is called the marginal probability. Probability, yes. Okay. This is called the joint probability. And this is, the probability of two events, two simultaneous events, probability of two simultaneous events. And where's my green? There it is. This, like I said, this is our joint probability. Am I running into my head? Probably. So I'm just gonna move this up. All right. So this might be like, oh God, why do we care? Well, hold on. Stick with me, because this is gonna get really cool. At least in my humble opinion, I think it gets cool. So we're also gonna need to think about, whereas this is like two events happening kind of at the same time, what happens if one event kind of influences or causes, or we want it to be connected to another event? And so in that case, we're gonna want the probability of event A happening given event B has happened. And so this is, I'll write that out, probability of event A given event B. We've also used this term before, but we haven't used, I think, some of this notation. We used it in the math proof, but it's okay if y'all weren't here for that. So this is our conditional probability, right? Because it's conditional. Depends on something happening. All right, so I think all this is it's notation, but it should be pretty, all right, okay, this makes sense. And so I'm gonna change colors. Let's change colors. Where's a pretty blue? There we go. Okay. So now if we wanna look back at our joint probability, right? So P of A and B. Well, we can think about this a little bit different. We can also kind of see that so we want both of these things, right? So that is just the probability that A happens given B has happened times the probability that B's happened. It kind of if you think about it, not worrying so much about how the math here is something or trying to math it. If you just think about it kind of intuitively, it makes sense, right? That the probability of these two events can be expressed instead as the probability that the one event has happened given the other event has happened, times the probability that that second event has happened as well. And so I think that's an intuitive way. And also it gives us a way to figure out the joint probability, the probability of A and B, using just the conditional probability. So similarly, let me see here, got to scroll down my notes, make sure I don't forget anything. We can also define the conditional probability, right? This is our probability of A given B has happened. We can also define this like inverse of this, basically. So P of A and B are joint probability all over the probability of B. So this is just some like, divide, right? So this is arithmetic. Even if the notation is more intimidating, it's just arithmetic. So, okay, but let's say that we don't know the joint probability, so we don't know this. No, we don't know this. But we want to still figure out what the conditional probability is. Well, this is where we're going to use Bayes' theorem. Yay, thank you, Bayes. And TWXGH, thank you for following. And so Bayes' theorem comes to the rescue. And it's just combining some of these rules and notation that we just learned. It's actually quite simple, but it's really beautiful in its simplicity. And great 8. Thank you for following. All right, so Bayes' theorem gives us a way of figuring out the conditional probability if we don't have the joint probability. So our conditional probability, right, our probability of A given B is going to be our probability that A happens, makes sense, okay, times the probability that B happens given A, right? So who remembers this is just the probability of right? So look back up here. Actually, you know what? Let me use some colors to show you this because I think this is gonna let me connect it with colors. Right? This is, right? Look at our definitions. This is just, there's our joint probability, okay? And so we know the definition of our conditional probability, right? From this is that joint probability divided by that marginal probability. So easy peasy. There you go. It's just combining those two definitions that we just learned. Simple, right? Easy, easy, easy. So there are some fancy words for some of these probabilities, and so I'm going to give them to you. We're not going to use them because, this isn't a statistics stream right now. And also, if you just popped in, I don't want you to be sitting here going, oh my God, what do all these words mean? So, but I will let you know at least what these are called. So this is called the prior probability. And the way that I like to think about this, whether it's right or wrong, and goal is 0. Ooh, is that a Dune reference? Thank you for following. So the prior probability, the way I like to think about this is if we're thinking what is the probability of A, and we're being very basic about it. What's the probability A is going to happen? But when we're looking at more complicated relationships, we might go, okay, now actually I see there's something else influencing this. So what is A given B? So the probability of A being our prior probability, I like to think about that as that's like our first assumptions. Like what is the probability of A independent, just like our baseline kind of hypothesis before we've done kind of any exploration. That's how I kind of remember that it's called the prior probability. And then this is called the posterior probability, because it happens post what we've learned. You might also see this marginal probability called this is the evidence, and this is the likelihood. In any case, really what you just need to take away from this is that when we are talking about the probability of one thing happening when it's dependent on other things, we're able to represent it really nicely without needing to know the joint probability thanks to Bayes' theorem. Now, you might be going, what the actual hell? I thought we were doing machine learning. How the heck does this have anything to do with sentiment analysis? Well, friends, instead of using, A and B here, let's be a little bit more specific. And we need a pretty color for this. Purple. What is the probability of our label given our features? Oh, suddenly it seems a little bit more relevant, right? So let's look. Okay, how do we do this? That's the probability of our label times the probability of our features. And I'll move this. I know this is probably, my head's blocking this. Given our label. I wrote this way too large. Weep. No one saw that. All over. That's not a straight line either. Woo. Close enough. All over the probability of our features. Now it seems more relevant, right? So while you might have just thought we kind of went off into the deep lagoon of random statistics instead of talking about machine learning, now that we phrase it like this, you can see how this is going to be used for classification, right? Because our label here, we're predicting a class given data, right? And Trickster, you ask, what program is being used for the whiteboard? This is Microsoft Whiteboard. Okay, so let's see here. Oh, one other example. This was the example I was thinking of earlier. Is let's say I am trying to figure out whether or not I'm building a cool food blog finder tool. Okay? And so, I want to know what is the probability of it being a food blog given that the word saute is in my corpus, right? And so that's the probability that saute would be on a blog in the first place. And Foamy93, thank you for following, times the probability of, no, I goofed this, didn't I? Yes, I did. No, I didn't. Did I just write it wrong over there? I did. I'm such a goof. Food blog over saute. No, I did do it wrong, right? Yeah, I did. Oh, silly me. Silly me. There we go. I was like, something doesn't look right. Something doesn't look right. All right. So what is the probability that it's going to be a food blog in the first place? Just basic. This is our naive, right? What's the probability it's going to be a food blog? Then what is the probability that the word saute would show up given our blog is a food blog? All over the probability that the word saute shows up at all. So that's another example, right? Is if we're interested in classifying blogs and we're going to feed it our text data, this is something, you can see how Bayes' theorem is going to come in handy. And so you might also ask, okay, why is it naive though? You literally just told me the thing's naive. Isn't that a bad thing? Well, naive here just means that we're going to make an assumption. We're going to assume that each of the features are going to kind of contribute independently to the probability of the label. So if I haven't said that, what is the probability this is a food blog given the words saute, chop, and oven are there? Well, we're assuming saute, chop, and oven are kind of independent, and they're going to contribute to the probability of this being a food blog independently. And so that might be let's see, just programming things. Thank you for following. That is actually a great segue into one of the cons of naive Bayes, which is that if you have feature correlation, or if you have non-independent combinations of words that are really important for your label, naive Bayes is gonna struggle. But like I said, it's fast, very lightweight in terms of time and storage complexity. Also, for all of you who've been slogging through the 12 days of machine learning myths with me, you will hear me about to say something I have not said at all, which is you don't have to scale your data. So yeah, I know. Those of you who have been here listening to me stamp it on your face that you need to always scale your data. You don't in this case. So that is also a nice perk. All right, so let's build this. Let's do the thing. Zoom back in. And Harry Brown asks, what is scaling data? All right, somebody who's been with us, or not, you know, if you're a newbie and you also know this, how about chat? You all tank this question, because I think lots of you in chat know this, because I've been on the scale your data rant for streams and streams. Okay. Alrighty. Let's see here. Well, MH Scenario, you say, why not attempt to compute the probability of the label given the feature merely based on the data? That is what we're doing. That is literally what we're doing. Yes, and that's a good way of putting it, just as good, Joe. So you say making sure everything is on the same level, that way features can be compared. So to give you an example, Harry Brown, if I have a data set, like a data set that we used previously, which is a Spotify data set, and you know, one of my features is the song length, so maybe it's in minutes, so 4.5 minutes. Then I have another feature that is the year, right? When we try to fit a numerical model to that, we don't want the model to somehow kind of interpret a year 2000 as somehow like so much more than this, you know, 4.5, like those aren't the same. Also, you might have a greater variation, like a 10-minute song. The distance between a 10-minute song and a 4-minute song is going to be so much greater than a distance of 10 years conceptually when it comes to music. So by scaling our data, by always kind of getting our features to be on a similar range of numbers, we're able to make more accurate comparisons, and our features aren't going to kind of disproportionately skew our model in one direction, or not falsely just because they're large or they're small or they have a larger range or something. Okay. So, yes, we have our training data, we have our test data. So let's get our naive Bayes classifier. And now you all know what that is. So now this, you know, this doesn't look completely like gibberish. So we're going to have our naive Bayes classifier, and we are going to train it on our training data. Easy peasy. So now let's see our accuracy. Did I goof this again? What did I do? Classify.accuracy. Oh, I goofed this before too, didn't I? Too many values to unpack. Classify.accuracy. Train. What did I goof here? Did I call? No, I didn't call anything that. Hold on. Oh, wait, what's test? Let me make sure, because I also, I called something else test earlier, and I shouldn't have done that. Don't be like me. Okay, that should be fine. So, you usually just you have to feed this your classifier, and you feed this your test data. No, it's still angry at me. What did I mess up here? Okay. Let's see here. Friends, let's debug. So, classifier, blah, 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 blah. Classify many, in gold. Too many values to unpack. Expected to. So, what's my structure of test again? So it is expecting this to be, oh, no, hold on, test. So that looks, no, that doesn't look right. Oh. Huh. Ha ha ha. So, standard error. You definitely caught me on this one. We forgot the last colon here. So I did forget a colon somewhere. Should have listened to you. There we go. Ah, that's fine. We can debug on the fly. And Goomba Stomp, thank you for following. All right. Wow. That's great accuracy, right? This is a data set designed for this purpose. So, but oh, isn't that wonderful? Wouldn't it be great if the real world was like this? Beechel, thank you for following. So one of the cool things we can look at, though, is we can look at our most informative features. Let's look at top 20. So looks like our emojis are very indicative, which makes sense, right? Let's see here. Via shows up in positive tweets. That's funny. That's really interesting. Let's actually limit this to the top 10 just so I can read it a little better. Let's get into the part of the night where Jess should be wearing her glasses and she's not. Hi, What a Weasel. Hello. I know, Kriegersaurus Rex. It's amazing what happens when we use data sets that are literally designed for this, isn't it? Oh. But also miss, okay, like tends to be in more negative tweets. All right. Enjoy. Arrived. That's funny. Thank. Okay. Please. Sick. And happy. Some of this makes sense. Well. Let's test this out, friends. So, and Stannis for King. Hydrate. Yes, friend. I will. So, oh no, look at this. You're getting behind the scenes view of my Twitter. So let's see here. I'm not going to use the Dota one. But let's see. I want kind of one that might be a little bit hard. Lots of politics right now. So this one might actually be a harder one. So let's use this. So we're going to do our test tweet. Oh, I'm going to have some backslashes here. Hold, please. Oh, all right. Freaking. This will make it easier for me to see. And there we go. All right. So there's our test tweet. And we're gonna need to. Actually, you know what, chat? You have stuck with me through this. What's our first step? What is our first step now that I have this test tweet? What do we need to do it? Let's test out a certain presidential Twitter account. Isn't that certain presidential Twitter account suspended? Just saying. All right, what's the first step, friends? Now I've made all of you NLP experts. What do we need to do to this tweet first? Step 1. And I mean, I can clean. Okay, we don't want to clean it first because if I just fed this to the, okay, so yes, standard error. So the word you're looking for is tokenize, but absolutely, we're going to split it up. So we're going to need our test tokens, right? Okay, so now we got our test tokens. What do those look like? There we go. Again, easy peasy, right? So next, we're going to clean them. Did this not work? Yeah, okay, so I had to do this a different way. So this is literally, I'm just copy pasting here the code from our function. The only difference here is that our function was expecting to take in lists of tokens, lists of tokens. And so in this case, I just tweaked it a little bit so that it would accept a single list. And Trickster, thank you for following. Okay, so now we look at our cleaned tokens. Okay, and you can see we still have this colon in there, which is fine. We could remove it if we wanted to be pedantic, but it should be okay. But that's because we also wanted to keep the chance of an emoji, so we don't want to strip out the emojis. All right, so now let's see how our little friend does. So So we're going to say we're going to classify it, but remember we got to put it in that strange format, right? So we're going to need to put it in a dictionary format. What did I goof here? Do I need to no. Generator has no object copy. Where did I goof it? I probably goofed something silly. Oh, I know what I did. I know what I did. Silly, silly me. No, so I've got this should be not there. So there we go. Whew. All right, so it claims, and I kind of like, I was grabbing this specifically because if you read the tweet, right, like it's got a lot of negative language in it. So is this negative or is this positive? And so already I'm kind of showing you one of the limitations of the way that we've approached it. We've approached it in this very binary way. What we might want to consider is perhaps having a degree scale of some kind, where like it goes from -5 to 5, -5 being like the most negative tweet, 5 being the most positive. And that way we would be able to get some nuance. Because this is like, you know, it's normal and healthy. Like this is kind of more of a negative statement, right? But this is more encouraging. Please go easy on yourself. Like this is very, you know, this is more positive. So let's find another. Let's find another tweet. Tweet. Everything's so negative right now because of course American politics. I found some happy ones earlier. Or like the dog tweets. We need some dog tweets. Come on. Someone talking about dogs. Not yes. There we go. Let's see. This is our new test tweet. All right. Our new twist tweet. I like this. All right, I'm excited. So let's see now. Positive. Exactly. Cute, non-menacing sun is a positive tweet. And so virtual assistant, you say you have to parse on punctuation to split sentences, then part sentences into words. So actually, no. And that is one of the beauties of tokenization, is that we are removing all of that kind of structure from it, which is more of like a human thing, and we're looking entirely at the paragraph as a whole. And so that is absolutely, that can be a downside, but it also is actually, it can be a positive. So we could, hey, don't be hating. That's a cute little cat. You know, we could talk about doing, it would be an interesting linguistics analysis to do what you're suggesting and do it on speech, because, you know, there's, you guys have all heard of like shit sandwich, right? When you're giving feedback, you kind of have the positive, the negative, and then the positive. So it'd be really interesting to do kind of what you're saying, virtual assistant. Split based on sentences. Treat the sentences separately. Feed them into a sentiment analysis, and see like the gradient of an utterance. So, for example, one of the things that I've heard a lot, especially in STEM and especially with femme people in STEM, is that there's a tendency to ask things like, well, you know, or to kind of do softening things at the end of statements. So it'd be very, very interesting to see kind of like, is it like negative, positive at the end, or how like, it would just be very, very interesting to do that kind of analysis. So you got me thinking, because you could almost see like the trends of sentiment as they change as someone talks. So that could be really cool. But at least for this case, for our tweets, that was a level of granularity that we did not need. So here you go. Here's your, you know, very basic introduction to sentiment analysis. And standard error, you say two sentences with the same words in the same order, but with very different placing of commas can have very different meaning. And that's another great point, right? So the steps that we take to simplify our, but here's actually, so standard error, I would disagree with you in one case, which is on social media, people are less apt to use accurate punctuation. And so rather than that, it makes more sense to train on the words themselves. But to your point, though, to like, you do have a good point there, which is that, you know, if we're working with text generation, or we're working with like very grammatically structured corpus, we might be concerned about things like our punctuation placement. But that's, again, remember how we've talked about this almost every stream, is that machine learning is often about trade-offs. And we are dealing with large-scale, unstructured data. We have to make some sacrifices to be able to get it into a format that we can work with a model. And so that's going to take some trade-offs, and those trade-offs are going to be so case-dependent. Robot Stevie, thank you for following, because there are going to be cases like you're all discussing in chat where we might want to drop the punctuation, or it's okay, it's not going to hurt us too much to do it. Other cases where it's vital. And so in that is why the more that you read like the intro tutorials and stuff, they always present things as hard facts. And that bothers me, because I don't think that's the way it should be taught. I think if you're teaching machine learning, instead of telling somebody like, you should always, tokenize in this way, you should always do this, or this is how you do this, it can create a lot of misunderstandings and false assumptions. Instead, kind of like present, and this is something I've really tried to focus on in these streams, is presenting the pros and cons of each approach, and basically being like, this is why this stuff can be hard to learn, and also why people hire folks who understand it, is that you have to know the trade-offs. It's way less like, do you know how to build sentiment analysis when you're working as a machine learning developer? And it's a lot more like, here's, a gross, noisy, very uncleaned, unstructured data set. What's the best approach to deal with this? And how do we get the best performance? So in that case, you have to be looking at your research question, the attributes of your data, computation limitations, storage or speed limitations, what kind of hardware this is going to be run on. And then you also have to think of all of those different trade-offs and how can I balance them to get the optimum result, and also, while still remaining true to what the need is and what the data represents. And so it can feel a little bit like a juggling act sometimes. And hi, Robot Stevie, say hi. Hi, welcome. And let's see. Yes, and so Oxide, you say, couldn't having confidence levels help with degree of positivity and negativity? Isn't naive Bayes probabilistic? It is, and so we could definitely do that. For this, I wanted a very straightforward, almost like binary classification approach, because it's a little bit easier to kind of just see that classification. But absolutely, so that is the beauty, right? Is that we can get, even with our logistic regression and everything, we got our probability of this particular class matching. Okay, so to review, we have talked about Bayes. So you've gotten like your little bit of like a little taste of Bayesian statistics, which this is where some statistics, I don't know. This is where statistics get fun. I used to hate statistics, and then I started doing more like Bayesian stuff, and I was like, oh, this is cool. But we've talked about natural language processing. We've talked about all the cool stuff it can do, the challenges, different approaches and strategies for breaking down a big problem into smaller problems, and also terminology that's common in tackling these fields. And also, you all, if you've been following along, built your first sentiment analysis model. So, where is X? Hi! Oh, wait, no. I gotta wait. I gotta wait for the reader to enter the chat. I'm good. I'm gonna be good. I'm not gonna jump the gun. See, I'm calm. No one saw me jump the gun. Because it's always good to wait a little bit so that the raider can enter chat. You know, as somebody, obviously, like we've done a lot of raids in my stream, and it always takes a second for the raider to be able to come into chat. Hi, Where's X? Thank you so much for your raid. Welcome, raiders. We are talking about natural language processing today, and I was just going over the things we had talked about, which we actually, you know, first time in the 12 days of machine learning miss, we are dipping our toes into the pool of Bayes, and we also built our first sentiment analysis model, and we learned how to lemmatize things, how to tokenize things, considerations when cleaning your data. We tested it on real tweets, which was kind of fun. Though right now, seriously, like Twitter, everyone is very upset, rightly so, but Twitter's mostly negative right now, so it was actually a struggle to find a positive tweet. But let's see here. So, I'm gonna move over to our just chatting. This is day 11 of the 12 days of machine learning miss. You all, a lot of you have been here for all 11 days. Some of you have joined in the middle and caught up, and even those of you who are just joining for day 11, it's been quite a journey. If you want to catch up on previous ones, you can go to YouTube, and the code and the Blackboard images for each stream are going to be on GitHub following the stream. So don't worry if you need to catch yourself up, like that is what all those resources are there for. And Stupak 62, you say that you want more days. Well, fear not, my friend, because after I maybe catch up on sleep just a little bit after the 12 days of machine learning miss, once I catch up on some sleep, we'll be returning to regularly scheduled stream content, which includes Science Sundays. So that might be, I'm thinking like, we'll have some Astro Sundays because everyone's got questions about space and black holes. But I might make some of those Sundays data science Sundays. So we can do more machine learning streams. And then we'll have math Mondays. I debated doing the math and machine learning Mondays because the alliteration's better. But I think we should stick with the math Mondays, being Mondays are all about math. Sundays can be for science, and that can include machine learning. So this will not be the end of machine learning. Also, for those of you who have been here for some of the previous streams, I've talked about some of the bonus streams that I'm going to be doing following this as well. So there's going to be a series that I need to plan and kind of sketch out, but it's going to be the reinforcement learning follow-up, and we'll be building a reinforcement learning system to play Doom, the game. Is that an M or an RN? M. Kemal. Thank you for following. And Tadaz V123. Thank you for following as well. And let's see here. Martin Eden, you ask, is it possible to say positive or negative for tweets with different languages? Absolutely. Unless I misunderstood your question. But, I mean, we would want to, obviously, our stop word dictionary would be in French for a French tweet, and we would train on French data. But we absolutely can do sentiment analysis on other languages. And black holes, I know everyone loves black holes. Absolutely. Yay! Thank you for the bits, virtual assistant. Thank you. Oh my goodness, all the hearts. I love it. And Onad, you ask about game streams. So I haven't finished Control yet. There's been no time for games. I've been working. So I'm back at work this week. And so that's meant a lot less time. So actually, every single stream day this week, so Monday and Wednesday and Thursday now, I get up in the morning. I go to work, which is like go into my office, but like I work, right? And then I prep for stream, and then I stream, and then I take a bath because I have a weakness for bubble baths, and then I go to bed. And so I've had literally no time for anything else. I've had no time at all. So I when was the last time I played a video game? I don't really remember. But that's okay. That's okay. I'm glad that I can bring all this machine learning goodness to all of you, so it is totally worth it. And Martin, you say the same AI working with multiple languages. So in that case, I would probably make an ensemble of models. And so that's something that we talked about in the stream where we learned about random forests. But an ensemble of models is, some different machine learning models working together. And so in that case, I would probably, kind of like how we made a forest of decision trees, I would probably have models for like sentiment analysis models for specific languages and then run them in ensemble based on the language. You might even have a pre-processing step there that is a pre-processing model that does language detection. So then you kind of remove a prescriptive layer there of having to have the person running the model specify what the language is. And so instead you can just feed the model the content. Your pre-processing step predicts does like a classification step and predicts the language and then calls the appropriate model based on language predicted. That's how I would handle that. Who needs video games when we have black holes? Well, you know what? I like my video games, okay? Video games, they help me relax. It's a nice way to de-stress. So, in any case, I have to confirm with my friend, but I'm really hoping that tomorrow for the computer vision stream, my friend who is a CV expert will be able to join us. He's great. This is like what he does every day, and computer vision is not what I do. So, I've done it. I've got certifications in deep learning for computer vision, but it's not something that I find myself doing frequently, at least not right now. So I wanted to bring on someone who was way more familiar with it. And also, because if you have more questions about computer vision, lots of people have been asking about it throughout the last 11 days. So I want to make sure we've got an expert that we can call on. We can phone a friend. So I'm hoping he'll be able to join us for tomorrow's stream on computer vision. And Fuzzy Purple Pixel, you say you're making a video game with black holes. Oh, that sounds so cool. I'm learning, so I mentioned how there's Science Sundays, Math Mondays. Thursdays are my chance to learn something, and that's where I'm learning game dev. So I'm learning Unity and C#, and I want to make a game with black holes. That'd be really cool. I want to make space-themed all the games. And Robot Stevie, you ask, is ML used for security? Yes. So it depends. I mean, obviously it gets more complicated than that. But it is very much used in cybersecurity and in physical security. So there's lots of cool applications for machine learning there. And Kriegersaurus Rex, you say you never did computer vision or NLP projects. Excited. I know, right? It's so good. I will actually, before I forget, like a forgetful person, and, I'm gonna text my friend and confirm that he's good for tomorrow. Because that's what responsible people do, right? We confirm things. And thank you so much, Soggy Cardboard, for following. You still up for tomorrow's stream? Okay, we'll see. So, and thank you, Fuzzy Purple Pixel, for following. I can't wait to hear more about your game. Let's see here. And Martin Eden, you ask, is it possible to create machine learning that understands coding language and codes just by itself? I mean, given what we're able to do with text generation, I would say yes. I'm not sure why you would do that though. Because, right, like, and Dabstabeat, thank you for following. Programming languages are kind of like a middle ground between us and the computer, right? So it's not 100% efficient to use. So you're kind of creating a lack of efficiency by making the computer code language that it's then going to use. Like, you might as well just interface with the computer directly, if that makes sense. Unless you're trying to like have automated maybe upkeep on large code bases or something, I would still say that while our NLP text generation models are improving, I don't think we're at the stage where we should cut humans out of the loop. So I'm a big fan of keeping humans in the loop until our machine learning is way, way, way more reliable. Okay, so as we are getting set up here, actually, for our raid, I hope that all of you will stick around. We're gonna raid Rub-a-Dub TV. This is somebody who has raided me a few times. So let's pass on the love. Let us, you know, pass the love of machine learning forward. Cheer this person on. He's pretty cool. And I will see you all tomorrow for computer vision, all right? So come back tomorrow and we'll celebrate the last day of machine learning, miss. So sad. Bye, chat. Have a good night.